Hello, and welcome to Space for Sleep. I'm so glad you're here. Whether you're settling into bed, curling up on the couch, or just trying to wind down after a long day of pondering the mysteries of existence, you've come to the right place. This is a quiet corner of the internet where quantum mechanics gets soft-spoken and the cosmos pulls up a blanket of stars. Tonight, we're exploring a question that sits somewhere between awe and fear. What would happen if a black hole, one of the strangest, most powerful objects in the universe, drifted into our solar system? Before we begin, please like and subscribe the channel for more interesting videos. Now, take a slow breath, let it out, and if you enjoy journeys like this one, remember to like this video and subscribe. It helps the universe of curiosity keep expanding. Now, imagine the familiar night sky. The planets trace their calm orbits, the moon glows softly, and the sun burns in quiet majesty at the center of it all. The distances are immense, yet everything moves in a delicate gravitational balance. But somewhere out there, in the dark between stars, something invisible is moving too. It doesn't shine, it doesn't reflect light, it doesn't announce itself, until it's already close. A black hole. To understand what might happen if one entered our solar system, we have to understand what a black hole truly is. Despite its terrifying reputation, a black hole isn't a monster waiting to swallow everything. It's the corpse of a star, a remnant of creation. When a massive star runs out of fuel, its internal furnace shuts down. The outward pressure that once balanced gravity disappears, and gravity wins. The star collapses inward on itself, squeezing matter tighter and tighter until atoms can no longer resist. The collapse doesn't stop until the star's core is so dense that nothing, not even light, can escape its gravity. That's a black hole, not a thing, but a region of space-time folded into itself. Most stellar mass black holes are only a few tens of kilometers across, yet they weigh as much as several suns. And they're not rare. The Milky Way alone is thought to contain hundreds of millions of them, wandering silently, unseen, in the dark between stars. Space, on human timescales, is almost empty and still, but over millions of years, even the most improbable encounters can occur. So what if, one distant day, a black hole happened to drift close enough to feel the sun's gravity? To begin, distance is everything. If a black hole passed a few light years away, say as far as the nearest stars, we might not notice at all. Its gravity would barely tug at the outermost reaches of the Oort cloud, that vast halo of icy bodies surrounding the solar system. But as it came closer, its influence would grow. Out beyond Pluto, billions of tiny icy worlds orbit in fragile harmony. Their orbits are already long and delicate. Even a gentle gravitational nudge could scatter them. A passing black hole, even one smaller than the moon, could send comets tumbling inward toward the inner solar system. We would see an increase in comets lighting up our skies, not because the black hole was attacking us, but because its gravity was stirring the deep cosmic dust. At this stage, astronomers would likely detect something unusual long before the black hole itself arrived. We wouldn't see the object directly, black holes don't shine, but we'd see its effect on light from background stars. As it moved through space, its gravity would bend and focus starlight, creating a brief brightening known as gravitational lensing. To our telescopes, a patch of stars would seem to shimmer strangely, as if space itself were breathing. Computer models would reveal that the pattern matched the signature of a massive invisible traveler, and panic would ripple quietly through every observatory on Earth. If we were lucky, the black hole's trajectory would show it passing harmlessly beyond the planets, maybe hundreds of billions of kilometers away. In that case, the solar system would merely quiver, and centuries later, everything would return to calm. But suppose it came closer, close enough to touch the outer planets, close enough for its gravity to compete with the sun's. At first, the outer giants, Neptune, Uranus, Saturn, and Jupiter, would feel the shift. Their paths, circular and steady for billions of years, would begin to wobble. Tiny deviations would grow into arcs, then loops, then new orbits altogether. Some moons might be stripped away, tossed into interplanetary space. Others could be captured by the black hole, orbiting a new invisible master. And what of the black hole itself? It wouldn't swoop in at high speed like a comet. It would drift, drawn by the sun's gravity. Once inside the solar system, the two massive bodies, the sun and the black hole, would begin a gravitational dance, circling a common center. If the black hole was small, the sun would remain the dominant partner. But if it were larger, 10 times the sun's mass or more, the entire solar system would shift its allegiance to the newcomer. The Earth would feel that pull almost immediately. Not in a sudden catastrophic jerk, but as a slow, relentless distortion of its orbit. Seasons would lengthen. The balance of day and night would shift. Over months or years, the rhythm of the planet's motion would unravel. Tides would change as the moon's orbit responded to the new gravitational field. The sky itself would tilt, the constellations subtly drifting from where they had always been. And yet, if the black hole remained distant enough, life on Earth might continue for quite some time. The sun would still shine. Gravity would simply be slightly misaligned. Perhaps civilizations would build new observatories, run new simulations, debate what to do as they watch the visitor inch closer year by year. But if the black hole approached within a few astronomical units, within the region where the giant planets orbit, the consequences would become unmistakable. Jupiter, the guardian of our system, might be the first to fall. Its immense gravity would lock with the black holes, stretching the gas giant like a droplet of liquid light. If the black hole grazed too close, tidal forces could tear Jupiter apart, feeding a disk of glowing gas around the intruder. For a brief time, the dark traveler would shine, a ring of incandescent plasma spinning around a void. The light from that accretion disk would be eerie and beautiful, ultraviolet and X-ray radiation streaming through space, a ghostly halo marking where gravity had consumed matter. Telescopes on Earth would register bursts of energy. Satellites would be blinded. The night sky would flare with a new artificial dawn. Closer still, the sun would begin to feel the competition. If the black hole were comparable in mass to the sun, their mutual attraction could destabilize both. The two would orbit each other, spiraling slowly closer as they radiated gravitational waves, ripples in space-time itself. Those waves would travel across the cosmos, faint but measurable, carrying news of our solar system's impending transformation to distant civilizations. For Earth, caught in between, the outcome would depend on geometry and luck. If the black hole passed on one side, it could sling the Earth outward, ejecting it into interstellar space, a frozen wanderer carrying traces of oceans and air into the dark. If it passed on the other side, it could drag us inward, pulling us closer to the sun or even toward the event horizon itself. Approaching a black hole isn't like falling into any other object. From far away, the pull feels ordinary. Gravity increases smoothly. But near the event horizon, space and time themselves begin to warp. If somehow humanity still existed to witness it, the view would be indescribable. The stars ahead would appear blue-shifted, their light compressed into brilliant streaks. Behind us, the universe would fade to black. Time would seem to slow. To an outside observer, the Earth would appear frozen at the edge, never quite crossing the horizon, stretched and reddened into infinity. But for us, time would continue normally as the planet spiraled inward until everything we know became part of the black hole's memory. The information contained in every atom of every being that ever lived would be preserved in the faint quantum patterns on the event horizon, perhaps not lost, just scrambled in ways we can't yet decode. The ultimate archive of a vanished world. It's a chilling thought, yet also strangely serene, because black holes, as terrifying as they seem, are also engines of rebirth. When matter falls in, energy is released. The accretion disks around feeding black holes are some of the brightest objects in the universe. They seed galaxies with radiation and momentum, sculpting the cosmos itself. Even if our solar system were destroyed, its material would not vanish. It would be transformed, recycled, and re-emitted as light and energy across space. In the grand view of the universe, destruction and creation are the same process seen from different angles. So perhaps the question isn't simply what would happen to us if a black hole entered our solar system. Perhaps the deeper question is what new story would begin. The atoms that once formed Earth might drift outward as radiation, joining the interstellar medium. Over billions of years, that material could collapse again into new stars, new planets, maybe even new forms of life. Every black hole, in a sense, is both a grave and a womb, a boundary where endings and beginnings blur. And so, as you imagine that invisible traveler moving silently through space, approaching our little solar neighborhood, remember, it's not a villain, not a cosmic predator, but part of the same universe that gave birth to us. It obeys the same laws, speaks the same language of gravity and quantum fields. Its arrival would be terrifying, yes, but also profoundly natural. The cosmos is not hostile, it's simply vast beyond measure. We exist in its calm middle moments, between explosions and collapses, between creation and decay. And somewhere out there, beyond the light of our sun, black holes wander patiently, waiting for their next encounter. As you drift to sleep tonight, think about that endless stillness, the quiet motion of gravity weaving its stories across time. The black holes are not coming for us right now. They're simply part of the universe's breath, expanding and contracting, shaping and reshaping the cosmos we call home. And maybe, one day, far in the future, when the stars have aged and the galaxies have dimmed, a black hole will indeed pass through the ashes of what was once our solar system. It will gather the dust, compress it, and send it back into the universe as light. And in that light, perhaps, some trace of us will shine again. If that thought fills you with wonder more than fear, give this video a like and subscribe for more quiet explorations of the deepest questions in physics and existence. Because here at Space for Sleep, even the end of the world can be a lullaby about how infinite and connected everything truly is. If a black hole were truly on its way toward our solar system, the first question humanity would ask is simple. Tibru. Would we know in time? Could we detect its approach before it was too late? The comforting truth is that space, even at its most dangerous, gives us warnings. The universe moves slowly on human timescales, and black holes, despite their invisibility, cannot sneak up completely unseen. Astronomers have ways to watch the dark. For all their silence, black holes have gravity, and gravity leaves fingerprints. Even when a black hole is completely isolated, far from any gas or stars to feed on, its mass still bends light that passes nearby. This bending, known as gravitational lensing, subtly distorts the apparent position and brightness of background stars. Imagine staring at a calm lake reflecting the stars above. Now drop a stone into the water. The ripples don't erase the stars, but they make their reflections shimmer and shift. A black hole passing in front of distant stars does the same thing, only with gravity instead of water. If you were looking through a telescope at a dense field of stars, you might see one suddenly brighten and fade again for no clear reason. That flicker would be your first hint. Something massive and dark had crossed its path. Astronomers already use this method to hunt for rogue planets and black holes wandering through the Milky Way. In 2022, scientists identified what might be the first isolated black hole ever discovered, not by seeing it, but by watching how it warped starlight for several months. It was about 5,000 light-years away, drifting quietly between the stars. Now, imagine the same effect but closer. If a black hole were within a few dozen light-years, its gravitational lensing might create patterns of subtle distortion in many stars at once. The Hubble and James Webb telescopes and arrays like the Vera Rubin Observatory would pick up the anomaly. A small team of astronomers, somewhere in the quiet of a mountaintop observatory, would notice something strange, an invisible mass bending space itself. They'd check their data, run simulations, calculate possible trajectories. And one night, in a room filled with the glow of monitors, someone would realize what it meant. The object wasn't just drifting near us. It was coming toward us. At first, the news wouldn't reach the public. The discovery would be verified quietly, passed between observatories, analyzed, rechecked. A black hole's motion can be deceptive. A tiny error in angle could mean the difference between a harmless pass and a direct encounter. But eventually, the data would settle into certainty. The coordinates would line up. The conclusion would be inescapable. Somewhere out there, in the star fields beyond Pluto, a black hole was heading for the heart of our solar system. The first response would be scientific. Papers would be written, conferences convened, calculations run in supercomputers. The second would be human, a mix of awe and dread. News outlets would carry the story. Talk shows would debate the timelines. Social media would turn it into noise. But behind all that noise, the astronomers would keep working, trying to answer the one question that mattered most: how close would it get, and when? The trajectory of a black hole isn't simple to predict. It's not a glowing beacon with an engine trail. It's an invisible mass moving through the gravitational fields of stars, planets, and dark matter. Even a tiny uncertainty in its position could grow into enormous error over decades. But with every new observation, the models would refine. If the black hole was still several light years away, humanity might have centuries, maybe even millennia, to prepare. If it were within a few trillion kilometers, the timeline would shrink to decades, and if it had already entered the outer edge of our solar system, the Oort cloud, we might have only a few years. How would we see it then? As it approached, the black hole would begin to reveal itself through its effect on the distant sun. Planets' orbits would drift ever so slightly. The outer comets, disturbed from their slumber, would rain inward. New long-period comets, never before seen, would begin appearing in the inner solar system, bright, fast, and frequent. At first, it would seem like coincidence. Then patterns would emerge. The outer planets would begin to shift their orbital timing. Neptune's position, Jupiter's resonance, Saturn's rings, all subtly out of place. Our best instruments, radio telescopes, gravitational detectors, laser-ranging satellites, would notice a faint, rhythmic pull in the background data. The sun's own motion through space would begin to curve ever so slightly. At some point, someone would say it out loud. The black hole had entered the neighborhood. What would we do? There are no weapons for this, no defense, no wall we can build against gravity. But we are a curious species, and curiosity might become our greatest survival tool. Humanity would start watching, not with fear, but with obsession. Every radio telescope, every optical sensor, every gravitational wave detector on Earth would turn toward the invisible visitor. Probes would be launched, long, thin arrows of metal and circuitry sent toward the darkness. They'd carry instruments to detect X-rays, gamma rays, gravitational ripples, anything that could tell us more. Perhaps, if the black hole were small enough, say, the mass of a few suns, it might begin to accrete gas from the interstellar medium, forming a faint, glowing halo. We would see it not as a black void, but as a pinprick of pale blue-white light, faint yet steady. To the naked eye, it might be no brighter than a distant star. But, through telescopes, it would shimmer with deadly beauty, a miniature whirlpool of space-time slowly spiraling inward. And yet, despite the fear, there would be fascination. Documentaries would stream across every platform. Artists would paint its imagined form. Writers would describe it as a god, a destroyer, a mirror. Some would find comfort in the idea that the end, when it came, would be cosmic and natural, not cruel. Others would see it as a reminder of how small we truly are. Governments would meet. Emergency plans would be written. But what could we really do? Escape? Even at our most advanced, humanity's spacecraft crawl compared to cosmic scales. The fastest object we've ever launched, the Parker Solar Probe, travels at about 700,000 kilometers per hour. At that speed, it would take over 6,000 years just to reach the nearest star. There would be no escape from a black hole entering our system. Our only refuge would be knowledge, to understand what was happening, to record it, to bear witness. If the black hole's path took it near the outer planets, we might have warning signs long before catastrophe. Jupiter's orbit, for instance, is a powerful gravitational anchor for the solar system. Any significant deviation in its path would disrupt everything else, like plucking a single string that unravels an entire web. We would see it first in the timing of Jupiter's moons. Astronomers track their motions down to milliseconds. A subtle drift would reveal that the entire solar system's gravity was being rewritten. Then Saturn's rings might begin to wobble, delicate ripples forming patterns never seen before. Further in, the asteroid belt could scatter. New comets would appear every week. The black hole's gravity wouldn't just pull on matter, it would pull on light itself. Stars behind it would seem to shimmer and stretch. Some might even form twin images, as if a ghostly duplicate had appeared beside them. This gravitational mirage would let us map its movement precisely, watching as it crept closer day by day. There would be an eerie beauty to it, watching space itself bend in real time, watching light perform its ancient dance around an object that cannot shine. By now, the world would be awake to what was coming, not just scientists, but everyone. You would see it in headlines: Fibreher rogue black hole predicted to pass near Neptune in 300 years. Earth's orbit may shift by 0.2%. Ebruch Global Space Agency's launch black hole mapping mission. Even though the threat might be centuries away, humanity would feel united by the enormity of it. After all, this wouldn't be a local event. It would be a cosmic one, the kind that humbles every border and every ideology. And maybe that would be the gift of it. For once, the human race would be reminded that we all share the same fragile orbit around the same star, and that even the mightiest of us are tiny compared to the universe. We would come together not to fight, but to observe, to send instruments into the dark, to learn everything we could before the visitor arrived. And while our descendants prepared, life on Earth would go on. Sunsets would still color the sky. Oceans would still breathe against the shore. The black hole would be far beyond Pluto, invisible but inevitable, the slow shadow of the cosmos, drifting closer year by year. It's strange, but there's something peaceful in that idea, that the universe gives us time to see our fate approaching, that even the end can arrive slowly enough for us to marvel at its beauty. And in that waiting, humanity might achieve its most profound discoveries. We would learn more about gravity, about space-time, about the quantum nature of black holes than ever before. The danger would be immense, but so would the opportunity to understand. Because that's what makes us human, the urge to look into the abyss, not to conquer it, but to know it. So if one day we learn that a black hole is truly heading our way, we may face it not with terror, but with wonder. We would watch the stars bend, feel our orbits shift, and understand, perhaps for the first time, what it really means to live inside a universe that is both beautiful and indifferent. And maybe, just maybe, in that moment of cosmic perspective, we would find peace, knowing that we were part of something unimaginably vast, and that every breath we ever took was, in its own way, the universe experiencing itself. So, if you're still awake, still listening, let that thought settle like starlight. Somewhere in the dark, the universe is moving, slowly, silently, and perfectly according to its laws. We are lucky enough to be here to notice. If that thought brings you calm, remember to like this video and subscribe to Space for Sleep. There's always another mystery waiting, and together we'll keep exploring them, one quiet wonder at a time. If the black hole continued its approach, the first real signs of its influence wouldn't come from light or even gravity we could feel directly, but from the subtle distortions in the architecture of our solar system itself. The sun, that immense, steady beacon of our existence, would begin to feel a rival tug. For billions of years, its gravity has ruled unchallenged. Every planet, every comet, every grain of dust follows its command. But now, another force, cold, invisible, ancient, would enter the stage. At first, the effects would be imperceptible. The black hole's pull would nudge the outermost edges of the solar system, the region we call the Oort cloud, where trillions of icy fragments orbit silently in darkness. These frozen relics of creation are loosely bound, fragile, waiting for any disturbance to set them adrift. The black hole's gravity would do exactly that. Far beyond Pluto, a slow awakening would begin. One by one, ancient comets would be shaken loose from their long sleep, their orbits stretched and twisted by the unseen visitor. Over thousands of years, they'd begin to fall inward, vast, glittering flocks of icy wanderers drawn toward the sun. To anyone alive on Earth, it might look like a sudden renaissance of the night sky. Comets would appear more often, some so bright they'd cast shadows. Astronomers would understand what it meant. The heavens were whispering, the balance had shifted. As the black hole moved closer, it would begin to disturb the orbits of the outer planets. Neptune, Uranus, and even Saturn. These giants, with their immense distances and delicate gravitational relationships, act as cosmic tuning forks. When they begin to drift, the harmony of the entire solar system starts to wobble. Planetary scientists would watch in disbelief as data began to deviate from predictions. Neptune would no longer appear exactly where the equations said it should be. Its orbital path would stretch just a little, one arcsecond here, another there, but the changes would accumulate. Soon, the gravitational resonance that keeps Jupiter, Saturn, Uranus, and Neptune in balance would begin to unravel. The solar system, once a clockwork of perfect stability, would start to lose rhythm. In deep space, the black hole would continue its slow, steady glide inward. Maybe it would pass within a few light days of the sun, maybe closer. It would depend on its trajectory. But the closer it came, the more violently it would reshape the solar environment. Its gravity wouldn't pull everything directly into it. Black holes are not cosmic vacuums. Their pull is only overwhelming if you wander too near. But even a distant pass could twist the sun's domain to chaos. Let's imagine a realistic scenario. Suppose the black hole is roughly the mass of our sun, about 2 nonillion kilograms compressed into a point no bigger than a city. Its gravitational influence would stretch across billions of kilometers. If it passed within 1 light year, the Oort cloud would be torn apart. If it came within half a light year, the outer planets could be displaced. And if it passed through the outer solar system, within the orbit of Neptune, the inner planets, including Earth, would feel the shockwave of gravitational disruption. The first to suffer would be the gas giants. Jupiter's immense gravity normally protects the inner solar system, catching comets and asteroids like a shield. But if a black hole entered its realm, Jupiter's orbit might tilt or stretch, sending chaos inward. The asteroid belt between Mars and Jupiter could become a storm of debris. Comets that would have missed Earth by millions of kilometers might instead find new trajectories that intersect our world. In the skies of Earth, over months and years, astronomers would chart these changes with growing dread. Cometary impacts would increase. Meteor showers would become intense, almost continuous. The night sky would burn with streaks of light, beautiful, terrifying, and historic. Meanwhile, the black hole's gravity would begin to affect the sun itself, not tearing it apart, not yet, but pulling on its orbit around the Milky Way. For the first time, our star would no longer travel alone. It would dance a slow, spiraling waltz with a partner so dark it could only be felt, never seen. If the black hole passed close enough, the sun's plasma could begin to warp, its outer layers subtly distorted by the tidal forces of spacetime. Solar flares might become more violent. The sun's corona, the vast halo of gas that extends millions of kilometers into space, could stretch and twist like a luminous ribbon. From Earth, the sun would look almost normal, but through the eyes of satellites, it would be visibly straining, responding to a gravitational duel millions of kilometers away. The real drama, though, would come later, as the two gravitational wells began to interact directly. If the black hole passed within a few billion kilometers of the sun, their combined pull would create a complex, shifting field of attraction. Planets that once orbited smoothly would find themselves caught in chaotic loops. Earth's orbit, for example, could elongate, moving us farther from the sun at one point, then pulling us dangerously close at another. That would spell climate catastrophe. A few % change in orbital distance could freeze oceans or boil them. Seasons would distort. The tilt of Earth's axis might wobble, throwing weather into extremes. Our world, so carefully balanced by distance and light, would fall into disarray. If the black hole came closer still, within a few 100 million kilometers, the solar system's fate would be sealed. Planets might be ejected entirely, flung into interstellar space, to wander forever as frozen orphans of the sun. Others could spiral inward, consumed by the black hole's tidal forces. Mercury, so close to the sun, would likely be the first to vanish. Then Venus, its dense atmosphere glowing one final time as it was stretched and shredded by tidal shear. Even the sun itself, if the black hole's mass were great enough, might begin to lose its outer layers. This process, called tidal disruption, would create one of the most spectacular sights in the universe. Gas torn from the sun would spiral around the black hole, forming an accretion disk, a glowing, whirling halo hotter than anything the human eye could imagine. It would blaze across the spectrum: visible light, X-rays, gamma rays, a cosmic wound radiating for thousands of light years. For a time, our solar system would shine like a miniature quasar. The energy released would outshine the rest of the Milky Way's stars combined, if only briefly. But beauty and destruction often travel together in the universe. The same energy that illuminated the cosmos would also obliterate the planets that remained. Radiation would flood space, stripping atmospheres, boiling oceans, sterilizing any world that had once harbored life. Earth, if it still existed at that point, would be unrecognizable. The sky would blaze with strange light. Magnetic storms would rage. The delicate dance of day and night would end. And then, silence. Eventually, the black hole would pass through. The sun, or what remained of it, would stabilize, dimmer and smaller, perhaps now orbiting its dark twin. The surviving planets, if any, would settle into new orbits, some circling the black hole, others bound to the remains of the sun. Our once familiar solar system would become something alien, a hybrid system of light and darkness, joined forever in a gravitational embrace. It sounds terrifying, and it is, but it's also profoundly beautiful. Because even in that destruction, the laws of physics would remain perfect. Every motion, every burst of light, every spiral of gas would follow the rules written at the dawn of time. That's what makes the cosmos so humbling. Even the end obeys its own elegance. But perhaps the most fascinating part is this. While such a black hole encounter would devastate our solar system, it's not entirely outside the realm of possibility. Astronomers estimate that our galaxy contains hundreds of millions of rogue black holes, remnants of ancient stars drifting silently through the Milky Way. Most are small, only a few times the mass of our sun, but some could be larger, heavier, and far more dangerous. The Milky Way is vast, 100,000 light-years across, and yet these invisible travelers move among the stars like ghosts. The odds of one passing close enough to disrupt our solar system are incredibly small, but not zero. And when we talk about eternity, about billions of years, even the rarest events become inevitable. That's the truth of cosmic time. Given enough of it, everything that can happen will. So maybe one distant day, a black hole really will drift into our system. Maybe it's already on its way, a dark ember from a long-dead star, still moving through the galaxy with no destination. If that day ever comes, humanity will be long gone. but perhaps something else, something new, will watch from another world. Maybe another species will look up at our faint, dying sun and see the strange light of our final moment, the glow of a civilization's homeworld consumed by the heart of a star. And they'll wonder, as we do now, what it must have looked like when a black hole entered our solar system. From Earth, the first signs of the approaching black hole would not be something anyone could see with their eyes. There would be no flash, no burst of light streaking through the heavens. It would begin instead with subtleties, the kinds of whispers that only the universe can make. Astronomers would notice first. They would look up and realize that the stars no longer behaved as they should. Constellations, so fixed and ancient, would begin to distort. The stars would not move, of course. They are far too distant, but the light from them would twist as it passed through warped space. To the naked eye, the sky might seem to shimmer slightly, as though reality itself were breathing. If the black hole came close enough, Earth's atmosphere would become the lens through which we watched the cosmos bend. Starlight would appear to ripple at the horizon. Some stars might appear twice. Others would stretch into faint, ghostly arcs. For the first time, humans would look up and truly see space bending under the weight of something unseen. As it moved nearer, time itself would begin to behave differently, not for us, but for anything falling toward it. The closer an object moves to a black hole, the more time slows from the perspective of a distant observer. It's a strange kind of cosmic compassion. Even destruction takes its time. If you could somehow watch a comet drawn into the black hole, you would see it fall forever, slowing endlessly, never quite reaching the edge. To you, it would appear frozen in the final moment before crossing the event horizon, stretched thin, glowing faintly, and then fading from sight. But to the comet itself, the fall would be swift, unstoppable, and absolute. That difference between what is seen and what is felt is the essence of relativity. Space and time, bound together like partners in a slow, eternal dance, twist themselves around mass. And in the presence of a black hole, that dance becomes extreme. To those on Earth, days and nights would still pass normally, at least at first. The black hole's gravitational field would stretch across the solar system, but its effects would come gradually, like a tide that cannot be rushed. The moon would continue to orbit. The oceans would still breathe. The sky, though, would begin to carry a quiet strangeness. Light would bend more strongly around the sun as the two gravitational fields began to interact. Eclipses might shift slightly in timing. The positions of planets, measured precisely by astronomers, would no longer match predictions. And then, one night, a faint new glow would appear near the edge of the constellation Sagittarius. A soft, diffuse halo of light that pulsed faintly, almost rhythmically. Through telescopes, it would look like a ring of shimmering fire surrounding darkness. It wouldn't be the black hole itself, of course, but the matter around it, gas and dust being drawn in, heated to millions of degrees as it spiraled toward oblivion. The effect would be breathtaking. Even in the calm of the night sky, the black hole would command attention. People would gather outside to see it, not out of fear, but awe. It would be like a new star, one born not from fusion, but from gravity's hunger. News broadcasts would show it every evening. Scientists would describe it in measured tones, explaining that the light we saw came from matter compressed and heated by unimaginable forces. They would tell us not to worry, that it was still far away, that it might never come close enough to harm us, but deep down everyone would feel it. The knowledge that something so powerful was on its way, silent and inevitable, would stir something ancient in the human mind, that instinctive awareness of cosmic scale and fragility. As the months passed, subtle shifts would continue. The outer planets would no longer follow perfect ellipses. Space probes near the edges of the solar system would begin sending back strange data, acceleration anomalies, faint drifts in trajectory, whispers of an invisible force tugging from the dark. By then, the black hole's gravitational influence would be measurable even on Earth. Radio signals from distant spacecraft would arrive a fraction of a second later than expected. light from the outer planets would show tiny distortions. These were not yet catastrophic signs, but they were proof that the visitor was real and getting closer. The night sky would grow more surreal as the months turned to years. Stars near the black hole's projected path would stretch into rings, like echoes of themselves. This gravitational lensing would make the region appear alive, starlight swirling gently in slow motion. Poets and scientists alike would find inspiration in it. Some would describe it as the eye of the universe, watching us. Others would say it looked like a doorway, not to destruction, but to understanding. Children would ask their parents what it was, and they would struggle for words. How do you explain to a child that the fabric of the universe can fold like cloth, that space can stretch and time can slow? How do you describe a force that bends light itself? Maybe we wouldn't try. Maybe we would simply look up together and watch it, silently, as generations before us once watched comets or eclipses, unsure of what they meant but certain that they mattered. The black hole would continue its approach. Eventually, its influence on sunlight would become visible even during the day. Shadows might grow sharper. As light curved slightly before reaching us, sunsets could stretch longer, painting the horizon with deeper reds and golds. Even the air itself would seem to shimmer faintly under the subtle warping of light. No sound would come from the black hole, no rumble or warning. Its silence would be its most haunting feature, a presence so immense it needed no voice. And yet, strangely, life would go on. People would still work, laugh, and love. Trains would run, cities would glow at night, oceans would roll to shore. But somewhere, in the collective consciousness, there would be a quiet awareness that we were living under a shadow. Not a literal one, but a cosmic one. It would remind us, perhaps, that we are temporary guests in a universe that moves according to laws far older and grander than us. Then, as the black hole crossed the boundary of the outer planets, its presence would become undeniable. Neptune's orbit would begin to distort. Saturn's rings, so delicate and precise, might begin to shimmer and twist. The very architecture of the solar system, the clockwork harmony that has governed it for billions of years, would falter. From Earth, though, it would still look beautiful. The sky would fill with faint, slow-moving wonders, comets on new paths, glowing dust arcs illuminated by the sun, and that shimmering circle of light around the black hole itself. And even as astronomers calculated its trajectory, even as they warned that the future was uncertain, people would still find peace in watching it. Because there's a strange calm in cosmic inevitability. When faced with something beyond control, the human mind sometimes lets go of fear and drifts into awe. You might find yourself standing outside one night, feeling the cool air, watching the stars bend slightly in their eternal dance. And in that moment, you'd feel something deep and quiet, the understanding that even if everything ends, it ends beautifully. If you're still here, still awake, take a slow breath. You are part of a story written in gravity and light, and the universe, in its vastness, is unfolding exactly as it must. If you found calm in this cosmic reflection, remember to like this video and subscribe to Space for Sleep. There's always more to explore, gently, quietly, and endlessly. As the black hole drifts closer to the heart of the solar system, it begins to whisper to the sun, not in sound, but in gravity, that invisible conversation that only celestial bodies can understand. The sun has always been the dominant force here, the great anchor of our cosmic family. For over 4 billion years it has ruled with steady brilliance, holding planets, comets, and dust in graceful obedience. But now, for the first time, something approaches that even the sun cannot ignore. At first, the dialogue is gentle, a faint tug on the outermost tendrils of the sun's magnetic field. The heliosphere, that vast bubble of charged particles streaming outward in every direction, begins to shimmer slightly. Subtle waves ripple through it, like a pond disturbed by a distant pebble. Solar winds, usually flowing smoothly past the planets, start to dance differently. Their patterns twist, guided by a new gravitational rhythm. Spacecraft near Jupiter detect these changes first. Their sensors pick up faint fluctuations in magnetic fields, a sign that the structure of space itself is warping. On the Sun's surface, the effects are mesmerizing. Prominences, those great arcs of fire that leap from its edge, begin to rise higher, drawn outward as if reaching for the unseen intruder. Sunspots grow more active, their swirling darkness a reflection of the tension building deep within the solar plasma. From Earth, these changes manifest in light. Solar flares become brighter, longer, and more frequent. For astronomers watching through specialized telescopes, the Sun appears alive in a new way, restless, breathing in waves of golden flame. The black hole's gravity does not pull at the Sun directly yet. It's still too far for that, but its mere presence alters the shape of the Sun's domain, stretching and bending the invisible web of fields that extends billions of kilometers into space. As those distortions ripple inward, they reach us. Here on Earth, the effects are subtle but undeniable. The auroras, those curtains of color that dance near the poles, begin to grow more vivid, more frequent. The skies over Alaska and northern Canada blaze with emerald light. In Scandinavia, the heavens ripple with violet and crimson. Even people living near the equator begin to see faint green glows at night, delicate traces of solar energy redirected by the changing magnetic geometry of space. Social media fills with images of auroras, breathtaking, otherworldly, surreal. People call them the black hole lights, unaware that what they're witnessing are the early echoes of cosmic interference. And yet, amid the beauty, scientists grow uneasy. Solar storms become unpredictable. Satellites experience brief communication glitches. GPS systems drift slightly off course. The invisible balance that makes our modern world function starts to tremble. The Earth's magnetic field, a delicate shield generated by the motion of molten iron deep below our feet, feels the strain. It begins to oscillate faintly, reacting to the Sun's changing output. For most of us, life goes on unchanged. But those who watch the skies, those who measure and calculate, begin to realize the solar system is no longer in perfect equilibrium. Still, for most people, this era feels like a kind of renaissance of wonder. Astronomy becomes the new poetry. Families camp under the night sky just to watch the auroras and trace the faint, ghostly distortion where the black hole's light ring hovers in the dark. It's strange how beauty and danger can coexist so easily in the cosmos. What threatens to unmake us can also be the most magnificent thing we've ever seen. Over time, the black hole's gravitational tide reaches the asteroid belt. The vast, silent stones between Mars and Jupiter begin to shift. Some are nudged slightly off course, others collide, breaking into glittering debris that reflects sunlight like tiny mirrors. For a time, the night sky becomes brighter, a faint silver haze around the ecliptic, born from collisions stirred by gravity's approach. Telescopes on Earth record these shifts with both awe and apprehension. The black hole, now visibly distorting the star field behind it, continues its steady journey inward. It's not rushing. It doesn't need to. Its gravity is patient, unhurried, eternal. As it nears the orbit of Saturn, the dance between it and the Sun becomes more complex. The Sun's outer layers respond like a vast ocean under the pull of an invisible moon. Plumes of plasma rise higher, solar winds intensify, and magnetic reconnection events, bursts of energy where field lines snap and realign, become breathtakingly powerful. For Earth, this means storms of charged particles sweeping through the upper atmosphere. Electronics in orbit begin to fail, space agencies issue warnings. Communication networks flicker in and out, like candlelight in a shifting breeze. And yet, for all its potential for chaos, there is also serenity in watching it unfold. Because from a cosmic perspective, this is not destruction. It is choreography. The Sun and the black hole our partners in a slow, magnificent waltz of physics. The solar system's structure, the orbits of planets, the flow of energy, the rhythm of time, is being rewritten by invisible hands. And as we watch, we are witnessing not the end of order, but the transformation of it. If you were to step outside during this era, the world might feel slightly different. Sunsets could appear softer, more drawn out. The light might seem to linger on the horizon, filtered through a subtly altered geometry of space. Clocks would tick as they always have, but time itself, the deep, cosmic kind that flows beneath all things, would be changing in ways we could never sense directly. In this gentle unfolding, we are reminded of how small we are, and how miraculous it is that we can notice any of this at all. The universe doesn't owe us understanding, yet somehow, through science and curiosity, we've learned to listen to its whispers. The black hole continues to move inward, now exerting measurable influence on Jupiter, the great guardian planet, the giant whose gravity has long protected Earth by catching wayward comets. But now, even Jupiter's strength is challenged. Its orbit shifts ever so slightly. Its bands of clouds, normally swirling in symmetrical patterns, begin to elongate. For a brief time, astronomers observe new storm systems on Jupiter, massive cyclones triggered by tidal forces stretching the gas giant's atmosphere. Lightning dances across its cloud tops in arcs hundreds of miles long. From Earth, through powerful telescopes, it looks like a living canvas of motion, light and gravity intertwined. And all the while, the black hole remains invisible to human eyes. We see only what surrounds it, the halo of light, the bending of space, the way it changes everything without ever being seen directly. That is perhaps the most profound truth of all. So much of existence, the things that guide us, the forces that shape us, are invisible. Gravity, time, emotion, thought, none can be held, and yet all define what we are. If you close your eyes and breathe deeply, you can imagine the calm weight of it all, stars moving silently in their great arcs, the sun breathing plasma, the black hole drifting inward, inevitable as the tide. And in that stillness, there's peace. Because even though the future of the solar system is uncertain, the universe continues to unfold exactly as it was meant to. If this moment of cosmic calm has eased your mind or stirred your imagination, take a quiet second to like this video and subscribe to Space for Sleep. It helps more people find this calm corner of the cosmos, where science becomes serenity and the infinite becomes intimate. By now, the black hole has reached the inner realms of our solar system. Its gravity, silent and unwavering, extends like an invisible hand through the orbits of the planets. And though the distances between worlds remain vast, Earth begins to feel that touch. It starts subtly, too subtly for most to notice. A fractional shift in the length of the year, a minute change in the path we trace around the sun. Nothing visible, nothing alarming. But to the instruments of scientists, it is unmistakable. Earth's orbit is no longer perfect. The rhythm of our planet, the gentle clockwork of day and night, begins to stretch and bend in response to something vast and unseen. The black hole's pull is faint but precise. It does not wrench or twist, it simply persuades. The geometry of space around us reshapes itself ever so slightly, and Earth follows the new curvature, like a boat gliding along an unseen current. For the people of Earth, life goes on. Cities glow, laughter echoes, seasons turn. Yet above all of it, the stars seem to shimmer just a little differently. The constellations remain familiar, but the spaces between them feel deeper, as if the night itself has grown thicker, heavier with the weight of gravity's presence. In the oceans, tides whisper of change. The moon still commands them, but now the black hole adds its faint rhythm, a secondary pulse barely perceptible. On certain nights, tides rise a little higher, linger a little longer. Fishermen along quiet coasts begin to notice. Waves arriving out of sync, the sea's breath ever so slightly altered. The Earth's magnetic field, hums faintly with a new tone. It's not a sound anyone could hear, but satellites detect it. Subtle oscillations in the planet's magnetosphere, as if the field were resonating to the black hole's gravitational hum. Deep beneath the crust, the molten core of the Earth, the great dynamo that powers our magnetic shield, spins in quiet sympathy, its patterns shifting by fractions of degrees. And yet, through it all, the world remains astonishingly serene. The black hole's approach is not an explosion. It is an unfolding, a cosmic tide, slow and graceful, rewriting the architecture of space. For those who gaze at the sky, this is a golden age of wonder. The black hole is now visible not just through telescopes, but faintly to the naked eye, a dim circle surrounded by a glowing halo of distorted light. It hovers near the path of the planets, like a dark jewel set against the stars. Amateur astronomers gather in parks and rooftops, their telescopes pointed toward that hypnotic shadow. Children peer through lenses, their eyes widening as they see the ring of fire around emptiness, a visual proof of gravity's poetry. Scientists work tirelessly to map its exact trajectory. Will it pass between Mars and Earth? Will it swing wide and leave our system untouched? Or will it brush too close, altering everything we know? The data shifts constantly. Every day brings a new refinement, a new equation, a new uncertainty. The black hole is not a solid object moving through empty space. It's a distortion, a moving wound in the fabric of space-time itself, and predicting its path is like trying to forecast the motion of a shadow cast on water. As it edges closer, light itself begins to behave strangely on Earth. Long-distance observations of distant galaxies start to waver, as if seen through rippling heat. Photons curve slightly more than before, deflected by the deepening warping of space. Astronomers who measure time using pulsars, those perfect cosmic clocks, notice that their regular pulses arrive a fraction of a second late. Across vast distances, even time is being stretched. But for most people, what they notice is beauty. The night sky glows differently now. The Milky Way, that river of light we've always known, bends subtly near the black hole's halo. To the eye, it looks like the galaxy itself is being drawn towards something unseen. And then, one night, something extraordinary happens. As the black hole's path brings it between Earth and the outer planets, the bending of light becomes so strong that the sky briefly doubles. The same stars appear twice, one true, one distorted, mirrored across an invisible line. It lasts only for a few minutes, but billions of people around the world look up and see the universe as it truly is, curved, dynamic, alive. The next day, there is silence. Not fear, but awe. People realize, perhaps for the first time, that the cosmos is not a still painting. It's a breathing organism. A field of energy and gravity that moves and changes like a living thing. Philosophers speak of perspective. Theologians find meaning. Physicists find confirmation. Everyone, in their own way, feels smaller, but also more connected. Meanwhile, the black hole's gravitational tides begin to subtly reshape the orbits of asteroids and comets that have long slept in the dark. Some are thrown into new paths, long, slow spirals that bring them closer to the inner planets. A few of them begin to fall sunward, glowing faintly as they heat. From Earth, they look like new comets, streaking across the twilight sky, their tails long and luminous. They are the messengers of change, reminders that even beauty is born from disruption. The Earth's atmosphere begins to feel the effects of the shifting solar winds. The upper layers grow slightly denser, absorbing more radiation from the increasingly erratic sun. Nights become fractionally warmer, auroras ripple even at mid-latitudes. Pilots report strange flashes of light in the upper sky, silent arcs of color that flicker like distant storms. Ocean currents adjust subtly. Patterns of airflow shift. Weather systems become slightly more chaotic, not in a catastrophic way, but in a way that feels alive. The planet is responding to the new cosmic rhythm, syncing itself to a deeper, slower beat. All of this unfolds over years, quiet, patient, inevitable. The black hole's shadow grows larger in the sky. Its ring of light brightens, fed by dust and gas drifting into its reach. The halo now glows with faint golden and crimson tones, like a fire seen through smoke. At night, it dominates the heavens. People lie awake just to watch it drift silently among the stars. It is not menacing anymore, it is mesmerizing, like a cosmic candle flickering at the edge of comprehension. And slowly, human beings adapt to it. Art changes, music changes, architecture, fashion, even speech begins to echo the imagery of distortion and reflection. The black hole becomes not a symbol of destruction, but of depth, of looking inward, beyond surfaces, into the unseen. Perhaps that's what the universe has always tried to teach us, that the invisible is what truly shapes reality. If you find yourself looking up and imagining this, imagining a night where space itself shimmers, remember, the same laws that would create this spectacle are the ones that allow atoms to exist, light to shine, and time to flow. The black hole doesn't only pull matter, it draws out understanding. It reminds us that even the calmest night sky is filled with motion, with curvature, with transformation, with quiet miracles too vast for words. If you've stayed with me through this journey so far, take a moment to breathe deeply. The cosmos is vast, but it's also home, and we are part of its story, no less significant for our smallness. And if this gentle descent into the heart of gravity's mystery has brought you calm or wonder, please like this video and subscribe to Space for Sleep. There's always more to explore together, quietly, one universe at a time. As the black hole approaches the sun's domain, the solar system begins to experience something it has never known. Two competing centers of gravity. The sun, radiant and ancient, has always been the anchor, the unmoving heart of everything. But now, from the deep, another force calls out, quiet, invisible, relentless. At first, it is a whisper of imbalance. The sun and the black hole do not collide. They orbit each other in a slow, mutual dance, their gravitational fields entwining across billions of kilometers. The black hole is smaller in size, but immense in mass. Perhaps a few times the weight of the sun, compressed into an object no larger than a city. The space between them becomes a vast, invisible sea of tension. Gravity flows there like wind, tugging at planets, moons, and dust. Every world now feels not just one pull, but two, one of light and one of darkness. From Earth, the sun still rises each morning, still paints the world in gold. But there is a subtle difference. Its path across the sky is slightly altered. The angle of sunrise shifts over months, just enough that astronomers can tell the sun itself is no longer fixed. It moves, a slow, graceful wobble across the heavens, tracing a pattern dictated by its gravitational duet with the black hole. The planets, faithful followers of the sun, begin to trace slightly distorted paths. Their orbits stretch and twist, caught between two masters. Mercury's motion becomes erratic, its already swift revolution turning chaotic. Venus gleams brighter in the twilight, its reflected light fluctuating as it dances along a slightly tilted path. And Earth remains stable for now. Our orbit elongates subtly, making winters longer and summers shorter. But to the human eye, the change is barely perceptible. Seasons still turn, days still dawn. The planet continues to spin in rhythm with itself, steady, dignified, unaware that the grand geometry around it has begun to rewrite. The black hole's gravitational lensing now dominates the night sky. It appears as a perfect circle of darkness, surrounded by an incandescent ring, the accretion disk, glowing with the last light of matter falling in. It's brighter now, its colors shifting from golden to deep violet, depending on the angle of observation. If you could stand on Mars and look toward the sun, you'd see two lights in the sky, one blazing and golden, one black and ringed with fire. Between them, a faint distortion, a trembling of space itself as gravity's fabric flexes and folds. Here on Earth, the sky becomes a theater of strange wonders. The constellations near the black hole's location seem to ripple, their stars duplicating briefly, stretched into faint arcs of light. Telescopes show distortions like mirages, galaxies warped into crescents and spirals of impossible symmetry. Photographers capture it all. The world is mesmerized. The black hole's halo becomes the most photographed object in human history. Artists paint it. Composers write music inspired by it. Slow, resonant pieces that mirror the rhythm of falling time. And yet, beneath the beauty, the solar system trembles. Because this new configuration, two gravitational giants locked in orbit, is inherently unstable. Over months, the black hole's approach begins to perturb the delicate harmony of the planets. Mars drifts slightly closer to Earth's orbit. Jupiter's immense gravity, once a stabilizing force, now amplifies chaos. The asteroid belt becomes a storm of motion, fragments colliding and scattering like sparks. Comets, ancient and icy, are drawn inward in swarms, their tails glowing fiercely as they approach the twin centers of power. For a time, the inner solar system becomes a light show. Streaks of flame against the black, each one a relic from the dawn of creation now returning to the fire. To the human mind, this spectacle feels both terrifying and sacred. Because even though danger looms, the sheer beauty of it, the elegance of cosmic mechanics playing out, overwhelms fear. The sun itself begins to sway under the black hole's pull. To an outside observer, it would appear to orbit an invisible point in space, its position gently oscillating as it and the black hole revolve around their common center of mass. It's not enough to extinguish the sun, but it is enough to change its rhythm. Solar activity surges and calms in irregular cycles. Flares erupt unpredictably, driven by tidal forces no solar physicist has ever modeled. The sun's corona, the ethereal atmosphere that stretches millions of miles into space, becomes asymmetric, one side drawn outward toward the unseen darkness. On Earth, that means more vivid auroras again. Nights shimmer with color, the air tingles faintly with electromagnetic charge. People begin to feel a strange intimacy with the universe, as if the cosmos itself were breathing nearby. Animals react subtly too. Migratory birds alter their routes by degrees. Whales, sensitive to the faintest changes in geomagnetic fields, begin to swim along unfamiliar currents. Even the patterns of lightning on Earth shift slightly. Bolts finding new paths through air that's been fractionally restructured by the magnetic flux. All of it is connected. Everything, from the smallest particle to the largest star, is woven together by the same geometry. And now that geometry is changing. For the first time, humanity witnesses gravity not as a constant, but as a variable, a living force that reshapes the architecture of reality. Scientists describe the solar system as entering a chaotic resonance, a condition where orbital paths become unpredictable over long timescales. Yet even they speak of it with reverence. There is no panic, only observation, as if the entire species has accepted its role as a witness to something sublime. The sun and the black hole continue their slow dance. They do not rush toward each other. They revolve, bound by physics so perfect it feels like art. Each orbit brings them infinitesimally closer, their gravitational embrace tightening across years, decades, perhaps centuries. During this phase, Earth becomes an island in a sea of distorted space. The moon's orbit elongates slightly, making tides more extreme. The air seems clearer at twilight, as sunlight passes through warped space and bends in subtle ways. Rainbows appear brighter, their arcs broader. Even color itself seems to have deepened. It is as though the universe, in its final act of balance, has decided to make everything more beautiful before it changes forever. At night, the black hole and the sun share the sky, one glowing, one devouring light. They are opposites, and yet they define each other. Without light, darkness cannot be known. Without darkness, light has no meaning. If you were to watch this from afar, from some distant galaxy, you would see a delicate cosmic duet, two massive bodies spiraling around each other, surrounded by tiny planets dancing in shifting patterns. You would see creation and entropy intertwined, each giving shape to the other. And here, on our small blue world, you would see billions of people standing outside in quiet wonder, knowing they are watching physics become poetry. Take a moment to imagine it. The hush of night, the vastness above, the faint curve of light around a shadow. In that moment, you are part of something immeasurable. You are gravity, you are light. You are awareness itself, watching the universe remember its own beauty. If this vision brings you peace, a kind of stillness in the face of infinity, take a deep breath. You are exactly where you belong, among stars, among questions, among wonders that never truly end. And if you wish to keep exploring this gentle edge between science and serenity, please like this video and subscribe to Space for Sleep. The cosmos has many stories yet to whisper, and we'll listen to them together. The days grow stranger now, though most people wouldn't say that immediately. The sun still shines, the seasons still turn, and the Earth continues its path around the shifting heart of the solar system. Yet something deep in the rhythm of time itself has changed. Sunrise comes a few minutes later each week, then earlier, then again later, as though the sky is breathing in a slow, unsteady pattern. Clocks, bound to Earth's rotation, keep perfect count, but the heavens no longer align with them as precisely as before. It is not chaos, not yet, but an unsettling deviation. Astronomers measure it first. Their instruments detect the oscillation of daylight, a subtle expansion and contraction of the sun's apparent path. The reason is simple, though profound: the sun's own motion around the new gravitational center created by the black hole's presence. For the first time in human history, daylight no longer belongs solely to the sun. At twilight, the black hole appears faintly in the east, its accretion ring glowing like an unblinking eye. It does not outshine the sun, but it commands a presence, an eternal dusk that hovers at the edge of perception. Sometimes during the deepest night, its lensing light bends around it in thin, ghostly arcs, creating false stars where none exist. Children point to it and ask their parents what it is. Some call it the mirror in the sky. Others simply call it the second sun, though it is colder, darker, and far more mysterious. Life on Earth continues, but not unchanged. Weather begins to feel slightly off. The jet streams drift from their normal lanes, shifting storms to unexpected regions. Some places grow wetter, others drier. Not dramatically, not yet, but perceptibly enough that farmers notice. Ocean currents, tied to wind and temperature, start to alter too. Warm water flows where it once did not, creating new climates along old coasts. Ice in the polar regions melts in new patterns, refreezing in others. Nature adapts faster than humans do. Birds shift migratory paths by instinct. Trees sprout at different times of year, following cues written in sunlight that now flickers subtly through a warping space. But to humanity, it feels almost supernatural, as though time and nature have become unmoored from their old certainty. Nighttime becomes longer in some parts of the world, shorter in others. The rotation of Earth itself remains constant, but the geometry of light has warped. The sun's apparent motion no longer perfectly matches the Earth's spin. They are out of sync by seconds that stretch into minutes, into hours. Some regions begin to experience what scientists call temporal distortion shadows. Not actual time shifts, but perceptual ones. Areas where the gravitational field of the black hole slightly affects the rate of time's passage. It's immeasurable to daily life, but measurable by atomic clocks. Time, once the most stable constant of existence, now has a gradient across the planet. And yet the world does not panic. Humans, surprisingly, are calm. Perhaps because the change is slow and steady, or perhaps because deep down, people have always known that the universe is bigger and stranger than they could ever imagine. Artists and writers begin to document what they feel. They describe a sense of cosmic melancholy, a quiet awareness of being small but significant, like a single ripple in an infinite ocean. Cities light up the night more brightly, as though to push back against the growing presence of the dark. Meanwhile, remote regions embrace it, finding new peace in the altered sky. Meditation retreats fill, observatories overflow with volunteers who simply want to look, to see the black hole with their own eyes. Governments hold meetings, space agencies share data, scientists speak not of danger, but of opportunity, the chance to study gravitational interactions at a scale never before possible. Probes are launched, carrying instruments to map the black hole's effects on the solar system. One such probe, Horizon Voyager 3, passes near Saturn and captures the most breathtaking image in human history: the sun and the black hole side by side, their light and shadow spiraling together like a cosmic yin and yang. The image becomes iconic, printed, framed, projected onto buildings, even tattooed onto skin. It becomes a symbol of balance in the face of uncertainty. Religions respond too. Some reinterpret their scriptures, finding metaphors for the black hole in ancient texts. Others see it as a sign, not of doom, but of transformation. Humanity, after all, has always sought meaning in the stars, and so a new era begins, the age of the twin suns. Not literal suns, but forces, one that gives light and one that bends it. As the years pass, gravitational harmonics between the black hole, the sun, and the planets continue to evolve. Earth's orbit elongates slightly more, stretching the calendar year by minutes. Seasons shift subtly. Harvest festivals move to match the new rhythm of light. Children born into this era grow up never knowing a sky without the black hole's faint ringed presence. To them, it is not ominous. It is beautiful. They draw it in school art projects, trace its glowing circle on paper, and dream of what lies beyond it. But not all consequences are gentle. Satellites in high orbit begin to drift unpredictably. Their trajectories bend in ways even computer models can't fully predict. Communication networks occasionally flicker, a reminder that gravity is not merely background, but structure itself. Space agencies begin to design compensation algorithms for time dilation to keep systems synchronized. GPS networks adjust continuously, measuring the infinitesimal but real difference between time near Earth's surface and time farther from it. And the deeper implication settles in. Einstein's relativity, once a theory, is now daily reality. Every person carrying a phone, every plane flying a route, every scientist marking the passage of time, all of them now live in a world where space and time are gently curved, flexed by the presence of something vast. For the black hole remains quiet, steady, patient. It does not feed yet, it merely waits, drifting in perfect harmony with the sun. But the balance is fragile. And far beyond the edge of the solar system, comets from the Oort cloud, icy remnants from creation, begin to fall inward, stirred by the dual pull of the sun and the black hole. They come in cascades, streaking across the outer planets like glimmers of memory. Each one carries the fingerprint of ancient time, frozen hydrogen and carbon compounds from the birth of stars. They burn in the atmospheres of Jupiter and Neptune, creating brief auroras, brief storms. In those lights, distant spacecraft still watch, silent witnesses in a cosmic ballet. And here, on Earth, beneath skies painted by twin gravities, life continues. There are births and celebrations. There are quiet nights and slow, gentle mornings. There are people who still make coffee, still laugh, still fall in love under the same stars, though those stars now shimmer through a slightly different geometry. Because that is what life does. It adapts, it finds balance, even as the universe changes shape around it. And maybe, in the quietest hours before dawn, when the sun and the black hole share the horizon, one bright, one dark, someone looks up and whispers the simplest truth of all: but we are not apart from this. We are part of it. The years slide by in quiet procession. The twin centers of gravity, The Sun and the black hole circle each other in silence, their orbits bound by the oldest rule in physics. From the outer edges of the solar system, dust and ice feel the pull first. It is gentle at the beginning, a faint tide that stirs what has slept for billions of years. In the darkness beyond Neptune, the black hole's invisible hand begins to draw filaments of matter toward itself. Microscopic grains of rock and frozen gas drift inward, forming faint streams that spiral through the cold. They glow only when struck by sunlight, turning the far edges of the system into a ghostly mist. Astronomers watch it unfold through deep space telescopes. They see a vast swirl, threads of pale light crossing the black. It is not violent yet, it is graceful, like the slow winding of smoke in still air. The black hole is beginning to feed. As this happens, the outer planets feel the faintest nudge. Neptune's orbit tilts by fractions of a degree. Uranus, already tipped on its side, wobbles in a new rhythm. Jupiter, massive and protective, absorbs the first wave of comets drawn inward by the shifting gravitational tide. Each impact sends plumes of color across its clouds, captured by cameras and broadcast to a world that cannot look away. On Earth, the effect is subtle, but measurable. The magnetosphere begins to fluctuate more frequently. Solar storms, once predictable, now arrive interlaced with deeper cosmic pulses, ripples of radiation released as the black hole's accretion disk flares. These are not deadly bursts, but they paint the sky with new intensity. Auroras extend farther toward the equator, swirling in crimson and violet bands. People gather at night to watch the heavens ripple. It feels less like a warning and more like a communication, as if the universe itself is speaking through color and light. Scientists learn quickly to read the patterns. Every flare from the accretion disk is mirrored by changes in the sun's magnetic behavior. The two giants are linked now, not just by gravity, but by resonance. When the black hole brightens, the sun's corona responds, its plasma streams shifting shape in answer to an unseen call. Across observatories, researchers whisper a single phrase with awe: "They are talking." No one means that literally, but the metaphor feels right. The sun and the black hole are locked in a conversation older than life, carried on in gravity and light. Each pulse, each flare, each whisper of radiation is a syllable in a cosmic language too vast for words. Down below, the effects ripple quietly through human life. Satellites must recalibrate daily, communication delays stretch by milliseconds, time dilation weaving its faint touch into the digital heartbeat of civilization. Clocks remain accurate, but engineers notice the tiny corrections that must be made more often than before. It is the first tangible reminder that time is not absolute, that even here, on this familiar Earth, relativity is no longer just theory but weather. In classrooms, children learn about the black hole as casually as earlier generations learned about the moon. They trace its orbit on digital globes, watch simulations of its dance with the sun, and understand, instinctively, that space is not empty. It moves, breathes, bends. Human imagination begins to change. Artists paint with gravity in mind. Architects design buildings inspired by the curving paths of orbits. Musicians compose pieces that follow the slow rhythm of gravitational waves, sounds that rise and fall in cycles of years. Culture, science, and wonder blur into one thing, yet the system itself continues to evolve. The streams of dust feeding the black hole begin to thicken. Tiny asteroids, once wandering alone, are drawn toward the central plane of the solar system. Some are captured by the black hole's gravity, forming a thin glowing ring, a faint accretion disk within the solar system itself. Through telescopes it looks like a new constellation, an ellipse of dim light circling the darkness. Humanity names it the halo of dawn. For the first time, the black hole has become visibly luminous in its own right, not through destruction, but through gentle accumulation. Energy from this process begins to reach the inner planets in delicate forms. Cosmic rays increase slightly, Radio interference rises and falls in slow, predictable waves. Nothing catastrophic, but unmistakably new. Scientists adapt, spacecraft shielding improves, communication arrays evolve. Humanity learns to live inside a breathing universe. At night, you can now see faint ripples in the stars near the black hole's position, optical distortions caused by gravitational lensing. The sky looks like liquid glass, bending, flexing. People start calling it the cosmic tide. In meditation halls and observatories alike, silence becomes reverence. For as the black hole feeds, it also hums. Not in sound, but in gravitational waves, tiny undulations of space-time that wash over Earth like distant music. Sensitive detectors record them as slow oscillations, patterns of rise and fall that repeat every few hours. When the data is converted into audible frequencies, the result is astonishing. A low, soothing tone, almost like a heartbeat heard through water. The media calls it the hum of the cosmos. It becomes the most streamed sound in the world. People listen to it as they sleep, meditate, or drift into thought. It replaces silence itself. For the first time, humanity rests to the rhythm of gravity. Governments no longer fear the black hole, they study it. Space agencies collaborate in ways unseen since the dawn of exploration. A new generation of telescopes, built on the moon's far side, free of Earth's interference, capture light so faint it reveals structures within the accretion flow. And there, among the swirling gases, scientists glimpse symmetry, spirals forming and dissolving like thought itself. They realize that the black hole is not chaos, but order hidden in curvature. Through the lens of observation, the universe seems to whisper, "I am not your enemy. I am the balance you forgot to see." Meanwhile, on Earth, weather stabilizes again. The shifting patterns that once disrupted crops now settle into a new equilibrium. Humanity, ever adaptive, has found harmony with the altered sky. Cities begin to dim their artificial lights so that people can see the heavens more clearly. Night preservation becomes a global movement. The sky is no longer something to escape, it is something to cherish. And each night, the black hole glows faintly, surrounded by its shimmering ring. It has become part of the human story, a mirror in the sky reminding everyone that even darkness can be beautiful. Yet deep beneath that calm, physics continues its quiet arithmetic. The sun and the black hole spiral infinitesimally closer. Their shared orbit shortens by centimeters each year, releasing gravitational energy that ripples across space like invisible tides. No one feels it, but detectors do. The hum grows subtly stronger. And so the universe continues to sing, softly, endlessly, a lullaby of motion and gravity. If you close your eyes and listen, truly listen, you might feel it too. The steady pulse beneath everything, the gentle rhythm that says, you are part of the cosmos, and the cosmos is part of you. Breathe in, breathe out. You're still here, still spinning in light and shadow, safe within the grand, slow heartbeat of creation. And as always, if this journey through the quiet wonder of physics brings you peace, don't forget to like this video and subscribe to Space for Sleep. There are infinite nights ahead, and each one holds another story the stars are waiting to tell. The solar system has now entered a kind of balance. Delicate but serene, the black hole and the sun circle one another in their slow, stately orbit, a cosmic waltz measured not in hours or days, but in centuries. At the heart of this new reality, light and darkness coexist. The sun's golden radiance pours outward, steady as ever, while the black hole curves that light into shimmering arcs, bending it around itself before releasing it again as echoes of brightness. This constant exchange of energy and geometry gives birth to a strange new kind of illumination, one that is softer, diffused, almost dreamlike. From Earth, the sky glows slightly differently now. Sunlight filtered through the subtly curved space carries a faint halo at the edges of every shadow. The blue of the daytime sky seems deeper, almost velvet in tone. Twilight lingers longer, its gradient smoother. A slow dissolve between light and night. Astronomers notice that even the moon reflects a new kind of radiance, the result of sunlight bending around invisible curves before touching its surface. Lunar eclipses glow more vividly, bathed in faint auroras of crimson and gold. Humanity, now several decades into the era of twin gravities, has learned to live inside this beauty. People have grown accustomed to the second presence in the heavens. The black hole's faint accretion ring, once a mystery, is now a comforting constant, a symbol of the quiet stability that can exist even in the company of immense forces. And yet, that stability is not perfect. It is dynamic, a balance of motion rather than stillness. The sun's output of energy has subtly adjusted, its fusion cycles, influenced by the tidal forces of the black hole's gravity, pulse in longer intervals. Solar flares are rarer but more symmetrical, their arcs tracing elegant patterns in the corona. Astronomers describe it as solar breathing, a rhythmic modulation in brightness that repeats every few years. On Earth, the effect is poetic. Seasons have softened. Winters are milder, summers less harsh. The tilt of the Earth still dictates the flow of warmth and cold, but sunlight itself seems to arrive more gently, as if filtered through compassion. Crops flourish. Photosynthesis adjusts naturally to the shifted light spectrum. Plants, sensitive to the faint changes in wavelength, produce new shades of green and violet. Forests glow with slightly altered hues. Emerald leaves shot through with a hint of iridescence under certain angles. Even the oceans change. The curvature of light through the black hole's gravitational field subtly alters how sunlight penetrates water. The sea takes on deeper gradients of color, with bands of turquoise and ultramarine that seem to shimmer with invisible motion. Divers describe it as swimming through moving glass, as if the water itself were aware of gravity's hidden dance. Marine life adapts in kind. Bioluminescent creatures glow with new brilliance, reacting to the black hole's faint electromagnetic hum. Some deep-sea species even evolved to synchronize their light pulses with the rhythm of gravitational waves, a phenomenon scientists call tidal photonics. Human civilization, too, begins to express this cosmic influence. Architecture evolves toward curves and spirals, reflecting the gravitational patterns that define their skies. Cities glow softly at night, their lights arranged to mimic the accretion ring, circles of calm illumination that fade toward the edges. Aesthetic philosophy merges with astrophysics. Art galleries display kinetic sculptures that slowly rotate in precise gravitational ratios. Music follows orbital mathematics, melodies that loop and return, never quite resolving, like planets tracing paths that never close. And through it all, humanity remains aware of its place in the larger picture. The fear that once accompanied the black hole's arrival has long since dissolved. What remains is a reverence, an acceptance that the universe can be both strange and kind. Science continues to probe deeper. Instruments stationed near Jupiter record that gravitational waves pass through matter differently depending on density. This discovery allows engineers to create gravity mirrors, fields that amplify or dampen space-time ripples for research. These mirrors don't produce energy, but they reveal something astonishing. The structure of space is not uniform. It has texture, almost like a fabric woven from invisible threads. Through these observations, physicists develop a new branch of study, quantum graviton resonance. The idea that particles of gravity, once thought purely theoretical, might interact with matter in ways subtle but measurable. For the first time, the link between quantum mechanics and general relativity feels close enough to touch. The black hole, by its silent presence, has become a teacher, a living laboratory where the two great pillars of physics finally meet. Across the world, classrooms teach these discoveries not as abstractions, but as stories. Children learn that they live in a universe that listens, one that responds to observation and interaction. And perhaps because of this deeper understanding, humanity's culture grows more peaceful. There is less urgency to conquer and more curiosity to comprehend. Exploration turns inward, not as retreat, but as reflection. Space travel continues, but with new wisdom. Manned missions orbit the black hole at safe distances, studying the curvature of space with instruments and meditation alike. Astronauts describe the experience as transcendental, a silence so profound it feels like communion. They send back recordings of the gravitational hum, its low, resonant pulse echoing like a heartbeat across the solar system. And down on Earth, that same hum plays in quiet homes and headphones, mixed into music and sleep playlists. People find comfort in it. They say it feels like the universe breathing with them. Yet beneath this serenity lies an awareness of inevitability. The black hole, though stable, is still drawing in matter. Over centuries, its orbit will tighten. One day, perhaps far beyond human lifetimes, the dance will end in a final merging. But for now, there is time. Time enough for civilizations to live, to grow, to dream. And as that thought settles in, there comes a kind of collective stillness. Humanity, for the first time, does not see the universe as separate. The old dichotomy between observer and cosmos dissolves. When you look up at the night sky now, you no longer see distant, cold points of light. You see the living geometry of existence, gravity and consciousness entwined. Perhaps that's what this whole journey has been about. Not the black hole's danger, but its lesson. That everything, from the flicker of a neuron to the orbit of a star, follows the same elegant curve. And so the nights continue, long, quiet, filled with light and shadow intertwined. The black hole's ring glows softly in the distance, a reminder of eternity suspended in motion. The sun rises as always, steady and golden, and humanity wakes beneath it, wiser, calmer, more connected than ever before. The cosmos hums softly, endlessly. And in that hum, you can hear the simplest truth. Hey bro, you are not just in the universe is in you. If this quiet voyage through light, gravity and existence has brought you peace, take a moment to breathe deeply and remember to like this video and subscribe to Space for Sleep. Together, we'll keep exploring the calm edge of the infinite, one whisper of science at a time. As the black hole glides deeper into the solar system, the first true signs of its presence begin to appear in the night skies of Earth. At first, it's nothing more than a whisper of darkness, a patch of stars that seems to shimmer oddly, as if seen through rippling heat. Astronomers notice it first, the constellations ever so slightly distorted, the paths of distant starlight bent by gravity's unseen hand. In the quiet hours before dawn, telescopes capture faint arcs of light around a region that should have been empty. Gravitational lensing, nature's perfect optical illusion, has arrived in our cosmic backyard. The black hole is not yet visible, but its influence paints the heavens with impossible curves. For the people of Earth, life continues much the same. The seasons turn, the oceans breathe, cities glow with human life and laughter. But in observatories and space agencies, tension builds. The calculations are undeniable. The black hole is moving inward, drawn by the sun's gravity like a moth toward flame. It's small, perhaps just a few times the mass of Jupiter, but density changes everything. Something so compact carries an invisible authority, a power that not even light can defy. The sun's outer magnetic field begins to quiver under the strain. Astronomers gather across continents, staring at computer models that twist and loop through simulated space-time. They run scenarios again and again. How close will it pass? Which planets will feel it most? Could it throw one of them free? Could it, impossibly, disturb the sun itself? The media spreads the story like wildfire. Overnight, the world becomes a theater of awe and fear. Some call it the second sun, though it shines with no light. Others whisper myths reborn, of cosmic serpents, of gods of darkness returning. But among scientists, the tone is one of reverent clarity. They speak softly of trajectories, mass, velocity and time dilation. They know that panic changes nothing. Gravity doesn't negotiate. Months pass. The black hole crosses the orbit of Neptune. The blue world trembles. Its outer atmosphere begins to ripple as space itself flexes around it. The planet's magnetic field flares, arcs of aurorae circling its poles in brilliant, ghostly sheets. On Earth, people watch live streams of those auroras, unaware that they are seeing light twisted by something that should not exist so close. The colors dance in silence, like farewell gestures from the edges of the solar system. Neptune's orbit begins to warp. Ever so slightly, the perfect ellipse stretches into an oval. Its years lengthen. And somewhere deep in the darkness, a whisper of heat blooms. Matter, stripped from the interplanetary medium, begins to spiral around the black hole. A faint disk of plasma forms, a ring of ghost fire, invisible to human eyes but roaring in X-rays. The black hole has entered the realm of giants, and its path now curves toward the inner worlds. Saturn feels it next. Its majestic rings, fragile and delicate, begin to respond to the new gravity. Waves ripple across them like wind over water. The planet's moons, each a small, icy world, dance in new patterns, their orbits twisted into strange harmonies. Titan's methane seas rise and fall, tides driven not by Saturn, but by something far darker. And yet, all of it unfolds in silence. No roar, no crash, just the slow ballet of forces beyond comprehension. From Earth, the sun appears unchanged, but deep inside its core, fusion wavers ever so slightly. The solar winds flutter, as if the star itself senses an approaching adversary. Astronomers predict that in another few months, the black hole will pass near Jupiter's orbit. That will be the true test. Jupiter, the king of planets, will meet the invisible king of gravity. When that time comes, telescopes across the world will aim toward the gas giant. Spacecraft will relay data in real time. Humanity will watch together as one of nature's oldest laws writes its lesson across the sky, that nothing, not even a star or a world, is beyond the influence of space-time's most silent predator. By the time the black hole nears Jupiter's orbit, the solar system feels subtly different. The great gas giant that has guarded the inner planets for billions of years now faces a rival that does not announce itself with light or color. Jupiter gleams in gold and amber beneath the sun, its storms rolling endlessly, unaware that something is bending the very fabric of the space around it. The first signs appear in its moons. Io, Europa, Ganymede, and Callisto begin to drift from their perfect orbital dance. The resonance that kept their rhythms in balance trembles. Radio telescopes on Earth pick up faint variations in their timing signals, a heartbeat of gravity gone slightly out of tune. At first it is only seconds, then minutes. The shifts grow. Jupiter's immense magnetic field catches the change even before its clouds do. Streams of charged particles that once arced smoothly across its poles now curve strangely, twisting like ribbons pulled by unseen hands. Deep inside the planet, pressure waves begin to move differently. The sound of the planet, a low, endless hum recorded by distant probes, changes pitch. And then from the outer darkness, the black hole reveals its presence, not through sight, but through distortion. Around Jupiter, starlight begins to curve. The gas giant's silhouette appears warped, stretched by the invisible tide. A faint halo of energy glimmers as interplanetary dust spirals inward, heated until it shines in X-rays. For the first time, humanity witnesses the dance of two gravitational monarchs locked in slow embrace. Every telescope on Earth and every satellite capable of vision in the high-energy spectrum turns toward the spectacle. Scientists watch the accretion disk form, a delicate, luminous ring around the black hole. Within that ring, plasma whirls near the speed of light. It glows in ultraviolet and X-ray frequencies, invisible to human eyes but captured by instruments orbiting above the atmosphere. In those wavelengths, the event looks like a cosmic eye-opening, calm and merciless. The encounter lasts months. At first, the black hole merely perturbs Jupiter's orbit. The planet wobbles, its year shortening slightly. Then tidal forces begin to stretch its outer atmosphere. The great red spot, a storm older than civilization, starts to unravel. Its spiral tightens, fades, reforms, and finally disperses into a band of chaotic turbulence. Jupiter's upper layers heat as hydrogen is torn into plasma and drawn outward in a thin, glowing stream. It is not violent at first. The gas flows gently, almost gracefully, forming a luminous bridge between the planet and the black hole. The stream arcs like liquid light, feeding the black hole's growing disk. On Earth, the images travel across every screen. There is no panic now, only awe. Commentators speak in hushed tones, as if describing a sunrise. People stay awake through the night to watch live broadcasts. The planet that once protected them slowly giving itself away to gravity. The sight feels sacred, terrifying and peaceful all at once. As Jupiter's mass bleeds away, the black hole's disk brightens. Swirls of matter trace the geometry of curved space, spiraling down into darkness where time itself slows. At the edge of the event horizon, the light appears to freeze, each photon stretched to infinity. Observers know that in the black hole's frame, everything happens normally, but from their perspective, Jupiter's last fragments hang suspended forever at the threshold of nothingness. When the accretion fades, silence returns. The black hole has gained only a small fraction of Jupiter's mass, yet the solar system's balance is changed forever. Without Jupiter's stabilizing gravity, the inner planets begin to shift slightly in their paths. Mars drifts outward, Earth's orbit becomes subtly more elliptical. It will take centuries for the effects to manifest fully. But the first calculations already show what will come. Colder winters, slower seasons, tidal patterns rewritten. Through it all, the black hole moves inward, continuing its serene trajectory toward the sun. It will not collide. The odds of that are infinitesimal. But its passage will stir the star's outer layers like wind across a flame. The sun senses it first. Deep in its corona, loops of magnetic fire stretch farther than ever before. The solar wind intensifies, then falters. Astronomers notice a rhythm, bursts of radiation followed by eerie calm. The heliosphere, the invisible bubble that shields the solar system from interstellar space, begins to pulse like a heartbeat. Within the next year, the black hole reaches the region between Mars and the asteroid belt. Millions of rocky bodies, silent for eons, start to migrate. Some are flung outward into interstellar space. Others drift inward on new, chaotic paths. For a time, the night sky of Earth blossoms with shooting stars as small fragments fall toward the inner worlds. Through telescopes, the black hole's gravitational lens becomes visible even to amateur observers, a perfect circle of warped light surrounding a heart of infinite darkness. It drifts slowly across the constellations, serene and unstoppable. For humanity, this era becomes known as the Great Passing, not an apocalypse, but a quiet confrontation with the scale of reality. People gather on rooftops and in fields to watch the heavens change, to feel the hum of gravity that connects them to everything else. Artists paint the sky as it bends. Musicians compose symphonies of slow, endless descent. Children learn the name of the object that has rewritten the solar system's history, not with fear, but with wonder. The black hole moves on, past the asteroid belt, past Mars. Its path now arcs toward the inner sanctum of the sun. It will not destroy the star, but its gravity will shape the solar atmosphere, drawing matter into flares that reach farther than any before. It will teach humanity a final lesson about time, light, and the beauty of impermanence. The black hole drifts inward, silent as a shadow, its path curved by the immense gravity of the sun. Space itself seems to sigh around it. The interplanetary medium, thin as breath, glows faintly as particles accelerate, following the pull of invisible lines. What began as distant curiosity is now an intimate presence. Humanity stands beneath a sky that subtly warps, as though the stars are caught in slow motion. The sun has never had a visitor like this. For billions of years it has burned in isolation, its domain ruled by the serene clockwork of the planets. But now, something older and denser approaches, a fragment of the cosmos that remembers the first fires of creation. At first, the black hole's influence seems delicate. The solar corona, that radiant crown of plasma, begins to stretch, filaments of fire reaching outward in impossible arcs. Astronomers watch in disbelief as magnetic loops elongate to millions of kilometers, drawn toward a darkness they cannot see. Solar winds twist, radiation bursts come irregularly, scattered like the breathing of a nervous giant. The rhythm of the sun, its steady heartbeat of fusion, falters and resumes, as if adjusting to the subtle tension in space-time. From Earth, the changes are subtle at first. Sunsets grow slightly redder. Auroras paint the poles more often, their colors deeper, stranger, not the gentle greens and pinks of ordinary solar storms, but veils of violet and gold. The atmosphere hums faintly with electricity. Satellites record small fluctuations in orbital speed, the whisper of curved space brushing against their trajectories. Then, one day, the sun sings. It begins with a sound not of air, but of vibration, oscillations in plasma that instruments convert into tones. The pitch lowers, then rises again, a sonorous chord that echoes through the solar system. The sun is resonating with the gravitational tide of the black hole. Space and time have begun to hum together. Scientists describe it in careful language, an interaction of fields, a transient resonance. But poets call it something else. The star's song of recognition, the meeting of two forms of eternity. The black hole passes near the outer edge of the sun's corona. Its accretion disk flares as it grazes streams of solar plasma, feeding briefly on light. The spectacle is breathtaking. A ring of gold and indigo forms around the darkness, the light of the sun itself bent and mirrored into perfect symmetry. For a few hours, from certain points on Earth, the sun appears doubled, one real, one phantom, as if reality itself is reflecting. Time slows, literally. Near the black hole, seconds stretch, photons curve into spirals, trapped in orbits that last forever from our perspective. Within that region, time dilates until even the motion of light becomes an illusion of stillness. The closer matter gets, the slower its clock runs. The sun's outer plasma flickers, then freezes, or appears to, in a moment that lasts forever to those watching from afar. On Earth, time continues normally, yet astronomers watching the event in real time feel as if they are witnessing eternity open like a flower. They see matter fall toward the black hole and never quite arrive, a paradox that embodies the very limit of perception. And then, slowly, the black hole passes. Its trajectory bends, pulling it into a long, graceful curve that will take it out of the inner system again. The sun, relieved of its tension, erupts in a vast coronal mass ejection, a final breath of fire. The flare expands across millions of kilometers, rippling outward in a glowing halo. Spacecraft shield themselves. On Earth, auroras ignite across every latitude. For one night, the entire sky dances. Cities fall silent. People stand outside, wrapped in blankets, watching curtains of green and violet light ripple from horizon to horizon. Even those who have never looked up before now feel the immensity of it, the sense that they are standing within something alive. The black hole, meanwhile, drifts onward. It has tasted the edge of the sun's fire, reshaped the balance of planets, and rewritten the gravitational symphony of the solar system. But it is not done. Ahead lies its exit path, a long arc that will take it past Mercury, then outward again into the deep dark. Mercury feels the strain next. The tiny planet's orbit distorts, its day growing even longer. Tidal stresses ripple through its iron core. The surface, long baked by the sun, fractures in new patterns. Dust plumes rise briefly and fall again, the quiet sigh of a world too small to resist. For a while, the black hole and the sun are bound together by gravity's invisible tether. They orbit a shared center of mass, the sun wobbling gently like a candle flame caught in a draught. But over months and years, the dark visitor begins to drift away. Its speed increases, its path carrying it back toward the outer void. On Earth, scientists measure the after effects. The sun's brightness fluctuates by a fraction of a percent, enough to shift climates ever so slightly. Seasons lengthen, the magnetic poles wander. The moon's orbit adjusts in response to Earth's new trajectory. Nothing catastrophic, but the solar system's clock has been reset. Generations later, textbooks will mark this as a cosmic encounter, the time when humanity witnessed the intimate power of gravity at its most profound. Not as destruction, but as revelation. In the years that follow, the black hole's memory remains in the mathematics of motion. Planetary paths no longer match their ancient predictions perfectly. Each carries a new eccentricity, a trace of that invisible hand that once passed among them. And then, centuries later, the last measurable trace fades. The solar system settles into a new rhythm, slightly altered, slightly colder, but alive. The black hole, now far beyond the reach of the sun, travels onward into interstellar space, a solitary wanderer carrying with it the faint echo of our star's light. As the black hole drifts away, the solar system exhales. It's almost imperceptible at first, a quiet easing, a release of tension that only instruments can detect. The fabric of space itself, once pulled taut, now relaxes. Gravity's tide softens. The sun steadies its flame. From the perspective of the black hole, nothing changes. It has no awareness, no sense of departure. It moves along the gradient of space-time, following the invisible geometry written by mass and momentum. But for those who live within the light, the absence is profound. The Earth's orbit, minutely altered, carries it through seasons that are now subtly longer. Days stretch by fractions of seconds. The oceans adjust their rhythm, tides recalibrating to the moon's slightly shifted pull. Life, as always, adapts. Trees still bloom, rivers still carve through stone, and children still look up at the sky with questions too large for words. But something has changed, not in the world itself, but in the minds of those who inhabit it. The encounter has left an imprint on the collective imagination of humanity. For the first time, people have witnessed, directly, the presence of an object that defies comprehension, not through myth or metaphor, but through observation. It humbles even the most seasoned scientists. Those who spent their lives studying black holes through equations and simulations now speak of them with reverence. They've seen gravity bend light into halos, seen time itself stretch thin at the edges of perception. They've watched a star sing to a void. In universities and observatories, new fields of study emerge. The event sparks a renaissance in astrophysics, quantum gravity, and cosmology. Instruments are redesigned to measure even fainter ripples in space-time, to catch the whispers of distant wanderers like this one. The boundaries of knowledge expand, fueled not by fear, but by wonder. On a quieter level, the event reshapes culture. Artists begin painting the invisible, curves of darkness framed by starlight. Composers write music that swells and slows, imitating the dilation of time near an event horizon. Poets speak of gravity as love, the unseen force that binds all things. And for the ordinary person looking up at the night sky, there's a new kind of awareness. The stars are no longer distant decorations. They are windows into a living, breathing universe, one that moves, evolves, and remembers. As decades pass, the black hole travels farther from the sun. It passes the orbit of Pluto, whose path has already shifted slightly from the encounter. The dwarf planet glimmers faintly in the sunlight, its ice plains casting reflections across the dark. For the briefest moment, the black hole's gravity catches some of that light, bending it into a luminous ring before it fades forever. Beyond Pluto lies the Kuiper Belt, a vast expanse of frozen remnants, leftovers from the solar system's birth. As the black hole glides through, its gravity stirs ancient objects from their slumber. Some are cast outward, ejected into the void. Others are drawn inward, sent on long, slow spirals toward the sun. One of these icy fragments, a small crystalline world no larger than a mountain, finds itself trapped in orbit around the black hole. For a while, it circles the darkness, glowing faintly with borrowed sunlight. Then, inevitably, it falls inward. To any observer nearby, it would appear to vanish in silence. But in truth, it is transformed, stretched, heated, and unmade, its atoms added to the timeless story of the singularity. By now, the black hole has reached the edge of the sun's domain. The heliosphere, the great bubble of solar wind, thins and fades into the interstellar medium. Here, between the stars, the density of matter drops to almost nothing. A single atom may drift for kilometers before meeting another. This is where the black hole belongs. The deep void welcomes it like an ocean taking back a wave. And yet, even out here, the memory of its passage lingers. Gravitational waves, faint ripples of space-time itself, spread outward, carrying information about everything that happened. Somewhere, hundreds of light years away, another civilization might one day detect those ripples and wonder, what was that? What happened there around that yellow star? They will never see our sun directly, but they will read its story in the tremors of reality. Back on Earth, generations have passed. The encounter is now legend, part of history, studied in schools, remembered in stories told under artificial skies. Humanity has moved beyond fear of the unknown. The event taught them something deeper, that existence is not about permanence, but participation. Everything, from a grain of sand to a black hole, plays its role in the unfolding of the universe. Cities have evolved. Energy no longer comes from combustion, but from the quiet mastery of fields once only theorized. Humanity has learned to manipulate gravity on a small scale, not to defy it, but to dance with it. Transportation, architecture, and even art now move in harmony with the geometry of space-time. And every year, on the anniversary of the black hole's closest approach, lights dim around the world. People look up, not in fear, but in gratitude, for the darkness that passed and showed them the light's true meaning. The event horizon has become a symbol not of doom, but of mystery, the ultimate horizon of understanding, always receding no matter how far knowledge extends. Scientists still chase it, building detectors in deep space to catch the faintest echoes of black holes colliding in distant galaxies. Each detection is a reminder, somewhere out there, the universe continues its slow, graceful waltz of creation and collapse. Far beyond the last traces of sunlight, the black hole continues its journey. It moves through regions of interstellar gas, through clouds of dust illuminated by the faint glow of nearby stars. It passes through fields of dark matter, unseen and silent. Around it, the galaxy rotates, a vast sea of stars swirling around a central, even greater black hole, the heart of the Milky Way. Perhaps millions of years from now, this wanderer will join that heart, falling inward, merging with it, contributing its mass to the great singularity that anchors our galaxy. When that happens, the memory of our solar system's encounter will be folded into the history of a much larger being, one that has seen countless stars rise and fade. But that story lies far in the future. For now, the black hole drifts on, a perfect silence moving through the dark, carrying within it the echoes of a star's song, a planet's devotion, and a species' awakening. And back on Earth, under quiet skies, someone lies awake, staring at the stars, remembering that once, long ago, a shadow passed among them, and for a brief moment, everyone understood what it means to exist in the presence of the infinite. Eons pass, the traces of humanity fade like mist under a rising sun. Cities crumble, oceans shift, and the continents drift in their slow tectonic waltz. The memory of people, their languages and their dreams becomes part of the sedimentary whisper of Earth. But the solar system endures, altered, quieter, and subtly transformed by the passage of that wandering black hole so long ago. The sun, once a youthful blaze, has aged into a deep, steady glow. Its heart continues to fuse hydrogen into helium, but the balance is shifting. With Jupiter gone, the dance of the planets has grown less stable, their orbits weaving new harmonies. Mars now circles slightly farther from the sun. Earth has cooled a little, its ice caps stretching farther south. If any intelligence were to observe from afar, perhaps machines left behind, or new minds that evolved in the long calm after humanity, they would see a system that has learned to breathe differently. Gravity's music has changed key. As millions of years turn into billions, the sun's luminosity increases. Ice melts, seas rise, and eventually the once blue world turns into a mirror of deserts and shimmering salt flats. Life, persistent as always, retreats underground, then into the oceans, then finally into the shadowed edges of the planet where warmth still lingers. Evolution writes its last verses in microorganisms and hidden colonies of light-resistant beings. All the while, the memory of that black hole's visit lingers in orbital data and gravitational imprints, tiny asymmetries in the motions of the planets that only the most sensitive instruments, long since dust, once recorded. And out in the void, the black hole continues its voyage. It has passed far beyond the influence of the sun, moving through the galaxy like a silent pilgrim. It drifts through nebulae, clouds of gas that glow softly in the light of nearby stars. As it passes, filaments of gas bend inward, spiraling briefly before dispersing again. The black hole leaves trails of faint, heated plasma, glowing ribbons that fade like sighs in the cosmic night. Eventually, it encounters another traveler, a rogue planet, cast adrift billions of years earlier from some forgotten star. The two objects, one of matter, one of absence, draw together in a slow, fatal waltz. The planet spirals inward, crushed and stretched into light before vanishing entirely. The black hole grows by a whisper of mass, unchanged, unfeeling, eternal. Time, at the galactic scale, becomes meaningless. The Milky Way itself evolves. Stars burn out, others are born, and vast arms of starlight rotate in stately grace around the supermassive black hole at the center. Gravity sculpts new patterns, merges clusters, and erases boundaries. Our wanderer, the small black hole that once brushed the sun, circles the galaxy countless times. Occasionally it passes near other systems, tugging at their outer planets, stirring comets, and writing new histories for other worlds. To them, it is just a shadow, a whisper of gravity moving unseen. To us, it is the echo of a story long finished. Back in the solar system, the sun approaches the end of its main sequence life. After 10 billion years of steady burning, its core fills with helium. Fusion slows, then changes. The sun swells into a red giant, its outer layers expanding until they engulf Mercury and Venus. Earth, now long lifeless, is stripped of its atmosphere and baked into silence. The sun's fiery envelope fills the sky with crimson light. Its beauty is tragic and immense. For a brief time, the inner solar system becomes a glowing nebula, a swirl of vaporized planets and dust, radiant and ephemeral. When the sun finally sheds its outer shell, what remains is a white dwarf, a diamond of compressed carbon and oxygen glowing softly in the dark. Around this ghost star, the remnants of the solar system continue to orbit, frozen fragments, rings of dust, and the dim outlines of moons that once danced around vanished worlds. The black hole that once passed among them is now halfway across the galaxy, its presence a distant echo. Trillions of years will pass before it encounters anything again. By then, the Milky Way and the Andromeda Galaxy will have merged into a single colossal spiral, a new cosmic city of light and shadow. Black holes, large and small, will populate its core, their gravity weaving a vast, invisible architecture. Eventually, as the universe itself ages, stars will fade. One by one, they will exhaust their fuel, leaving behind white dwarfs, neutron stars, and black holes, the final, quiet citizens of time. In that far epoch, when the night sky has gone dark and galaxies themselves have dimmed into invisibility, the universe will be a realm of silence. Black holes will be the last structures of meaning, holding within them the memory of everything that once was, matter, energy, even the patterns of thought that once looked upon them with awe. Our small black hole, the one that passed by the sun, that taught a civilization the beauty of gravity, will continue to exist. Its event horizon will remain smooth and silent, a perfect boundary where space meets mystery. Inside it, everything that ever fell in, starlight, gas, fragments of worlds, will remain, encrypted beyond recovery, written in the geometry of space-time. And though it will never speak, the black hole's mere existence will be a testament to the persistence of the universe's first and oldest law, that nothing is ever truly lost, only transformed. Eventually, even that will change. In the deep, cold future, black holes themselves will begin to evaporate through a faint glow known as Hawking radiation, the final whisper of physics before silence. For our black hole, this process will take longer than the age of all galaxies combined. But time by then will have no meaning. When it finally evaporates, its mass will return to the cosmos as a gentle sigh of energy, the last breath of a story that began with stars. And perhaps, somewhere in that final whisper, there will be a memory. Not of destruction, but of connection. Of the moment when a small world, circling a yellow star, looked into the infinite and understood that even darkness can be beautiful. Billions of years drift by, silent as falling snow. The Milky Way and Andromeda, once radiant spiral galaxies, have long since merged into one vast elliptical cloud of fading light, Milkomeda. Its brilliant core glows faintly, a city of aging stars surrounded by long shadows where starlight once flowed. The great river of light that was the galactic disk has become a sea of embers. Our wandering black hole, once an intruder to the solar system, now an ancient pilgrim, circles this merged galaxy, gliding through fields of faint starlight. It passes remnants of civilizations long vanished, perhaps traces of others that arose and fell in the eons since humanity's time. All of it silent, all of it dust. Far from the galactic core, the remnants of the sun continue their slow dimming. The white dwarf that was once our star has cooled for trillions of years, turning from brilliant white to dull red, then to black. It has become a black dwarf, a frozen sphere of carbon and oxygen, no longer shining, but still holding the gravitational echo of what once was. Around it, the ruins of planets and moons continue to orbit in perfect stillness, frozen and unchanged. The galaxy is quieter now. New stars no longer form. The gas clouds that once birthed suns have long been consumed or dispersed. The great cycle of birth and death that defined the universe's middle age has come to an end. What remains is a kingdom of shadows, black holes, neutron stars, and the faint ghosts of once luminous suns. Yet the universe itself continues to expand. Space stretches carrying galaxies, or what's left of them, farther and farther apart. The cosmic background radiation cools to near absolute zero. The last light of the Big Bang fades into darkness. In this long twilight, black holes rule. They are the anchors of existence, the last gravitational wells in a universe that is slowly emptying itself. Their horizons shimmer faintly with Hawking radiation, that subtle quantum process by which they give up their mass, particle by particle, photon by photon. The smaller black holes die first. They shine briefly, a flash of gamma rays, a final radiant exhalation, then vanish. The larger ones endure longer, their deaths postponed across unimaginable spans of time. Our black hole, though small compared to galactic titans, is still vast enough to persist through trillions upon trillions of years. It drifts through the cold dark, no longer interacting with anything. The stars too far, the gas too thin, the light too faint. It is utterly alone. Inside its event horizon, time has lost meaning. The singularity at its core, that infinite compression of space, remains hidden, sealed off by gravity's perfect curtain. To an outside observer, nothing happens. To what falls in, everything happens at once. And yet, even now, the laws of quantum mechanics continue their subtle work. Virtual particles flicker in and out of being near the horizon, stealing a fragment of the black hole's energy with each exchange. Slowly, impossibly slowly, it begins to shrink. The end of time itself becomes the backdrop for this final act. Galaxies fade completely. Black dwarfs cool to match the background temperature of the void. Even the occasional collision of remnants becomes rare, then ceases entirely. The universe has become a vast, dark sea of almost nothing, the black hole era of cosmic history. For uncountable eons, our black hole remains. Its existence is no longer dramatic, but meditative. It has become the last structure of consequence in a silent, expanding cosmos. Eventually, even this will end. When the universe is so old that numbers lose their meaning, when time has stretched beyond 10 to the power of 100 years, even the supermassive black holes at the centers of galaxies begin to die. Our traveler follows them, one of the last. It grows warmer as it shrinks, paradoxically brighter in its final moments. The faint glow of Hawking radiation gathers strength, becoming the only light in the entire universe. For a few heartbeats of cosmic time, it shines, a pinprick of radiance in infinite blackness. And then, it's gone. What remains is not destruction, but transformation. The energy released by the black hole's death spreads outward, joining the thin soup of radiation that fills the endless void. The universe becomes smooth again. No structures, no stars, no light. Just quiet equilibrium. Some physicists call this the heat death of the universe, a state of perfect uniformity where entropy has reached its maximum and no more work can be done. Others imagine stranger futures, quantum fluctuations birthing new universes from the vacuum, space-time itself folding into new beginnings. But in every story, there is a common thread. Even in silence, potential remains. The end is never absolute. The same laws that gave birth to stars and life could one day awaken again, in another form, in another place, beyond our knowing. So when we ask, what if a black hole entered our solar system? The answer is not only about gravity or destruction, it's about perspective. It's about seeing our place in an immense, evolving universe and realizing that we, too, are temporary visitors. And maybe that's the quiet beauty of it all. Just as a black hole consumes and transforms everything it touches, time does the same to us. The atoms that make our bodies were forged in stars that once lived and died long before Earth was born. The same forces that tear galaxies apart also hold our cells together. We are, in a very literal sense, the universe becoming conscious of itself. For a brief, flickering moment between two eternities of darkness. So as we close our eyes tonight, listening to the hum of existence and the silence between thoughts, we can remember this. Abroch, everything changes, everything returns. And somewhere, in the endless night beyond the stars, a black hole drifts, patient, eternal, and beautiful. Imagine now that everything is quiet. No stars, no planets, no light. The story of the universe has reached its still point, but that doesn't mean it's over. It only means the music has shifted to a single, sustained note. A note that's too deep, too long for any ear to hear. And yet, even here, in the hush between beginnings, something remains, the memory of motion. The memory of what it was like to shine. When we talk about black holes, it's easy to imagine them as destroyers, the ultimate agents of oblivion. But that isn't quite right. In truth, a black hole is a kind of preservation. It takes in everything that crosses its horizon, all the matter, all the energy, all the stories, and folds them into the geometry of space itself. It doesn't erase, it encrypts. The information is still there, written into the curvature of space-time like a cosmic archive. And that's what makes them beautiful. Black holes are not endings, they are transformations. The universe's way of remembering without needing to speak. If you are floating there, in the final darkness, listening to the echoes of long-dead galaxies, you might realize something quietly profound. Everything that ever happened still is. Every particle that ever existed still hums with its connection to everything else. The past doesn't vanish. It only becomes hidden, folded into layers of time we can no longer touch. That same pattern lives in us. Every heartbeat, every thought, every breath you take is part of a chain that stretches back to the first atoms born in the Big Bang. You are made of hydrogen from the dawn of time, carbon from the cores of stars, calcium from ancient supernovae. When you look up at the night sky, at least the night sky that was, you are seeing fragments of yourself. And that is why the thought of a black hole entering our solar system is both terrifying and sacred. It's not only the story of destruction, it's a mirror held up to everything we know. It asks the biggest questions. What are we made of? What lasts? What does it mean to exist, even briefly, in a universe so vast and mysterious? The answer, whispered by the cosmos itself, is that existence is not about permanence. It's about participation. We are temporary expressions of something infinite, waves on the surface of space-time, dancing for a while before fading back into the ocean that made us. In the same way, every black hole is a wave too, a ripple in the field of being, bending the rules but never breaking them. Each one is a paradox that says, the universe is both knowable and unknowable, intimate and infinite, fragile and eternal. And maybe, just maybe, that's the point. The great physicist John Wheeler once said, black holes are where God divided by zero. It was his poetic way of saying that in these objects, our equations, our understanding, reach their limit. But perhaps the truth is even simpler. Black holes are the universe teaching us humility. They remind us that there will always be more to learn, more to imagine, more to feel. They remind us that mystery is not a flaw in our understanding. It is the very heart of it. So when we talk about the black hole that might one day pass by our star, we are also talking about the black hole within our own awareness, that infinite depth of not knowing that makes curiosity possible. In that way, quantum mechanics and black holes are not enemies of wonder. They are its guardians. They show us that reality is not a flat surface to be mapped and measured, but a living fabric that invites us to look deeper, always deeper. And the deeper we look, the more we find that the boundaries between things, between light and dark, between life and death, between mind and matter, are softer than we think. The atoms that once lived in stars now live in us. The particles that fall into black holes might one day escape as radiation. The information we think is lost might only be waiting to return in another form, another world, another breath. The universe is not a straight line. It's a circle of endless transformation. So if you're listening now, somewhere in the dark, perhaps lying in bed or sitting by the glow of a distant screen, take a moment to breathe. Feel the gravity of the Earth beneath you, the same force that holds planets in orbit, that shapes galaxies, that forms black holes. You are feeling the same field that binds the entire universe together. Let that thought rest in your mind like a soft light. You are not separate from the cosmos. You are an expression of it. Every atom in your body has danced through stars and voids and time itself to arrive here in this single perfect moment. And that means, in the most literal scientific sense, that when you look at a black hole, the universe is looking back at itself. If you could float in the dark spaces between galaxies, far from any sun, where the only sound is the whisper of your own breath, you might begin to feel it, the stillness that lies beneath everything. It's not emptiness, it's potential. That's what quantum mechanics has always tried to tell us. Even in the void, even in what seems like nothing, there is always something. A shimmer of energy, a field of possibility, a trembling uncertainty that never stops moving. Every atom in the universe, every photon, every grain of dust arises from that restless foundation. It's as if existence itself is a conversation between nothing and everything, a constant dance between being and becoming. When we talk about black holes, we're really talking about that conversation carried to its most extreme conclusion. They are places where the ordinary rules break down, where time stretches, space folds, and the quantum world whispers to the cosmic one. And in that strange intersection lies a kind of beauty that's hard to describe. It's not the beauty of simplicity or symmetry. It's the beauty of mystery, of realizing that the more we learn, the more there is to learn, that the further we travel, the deeper the horizon becomes. Black holes remind us that curiosity is infinite, that every answer opens another question, that understanding is not a destination, it's an endless journey through wonder. Perhaps that's why people have always looked up at the night sky with such longing. The stars are not just points of light, they are questions made visible. Each one asks, where did we come from? What are we? What comes next? And the truth, as far as science can tell us, is both simple and profound. We come from the same stuff as everything else. The same quantum fields, the same cosmic dust, the same burst of creation that set the universe in motion. The atoms that make up your hands once drifted through nebulae. The iron in your blood was forged in a supernova. The calcium in your bones once lived inside a dying star. You are not separate from the universe. You are its story told in the language of consciousness. So when you imagine a black hole passing through our solar system, don't think only of what might be destroyed. Think also of what might be revealed. Of how such an encounter reminds us of our fragility, yes, but also our connection to everything. Because that's the real miracle, that fragile things can exist in such an immense, powerful universe and still feel wonder. Maybe that's what consciousness is for. Maybe it's the universe's way of slowing down enough to look at itself and whisper, wow. And when you see it that way, even fear becomes something sacred. The fear of the dark, the fear of the unknown. It's not a flaw in us. It's evidence that we know there's something more. That our awareness stretches farther than our senses. So, in the great story of the cosmos, maybe black holes aren't the villains at all. Maybe they're reminders that even when light disappears, the story doesn't end. It continues, unseen, inside the gravity of something larger than we can imagine. The physicist Roger Penrose once described black holes as the most perfect objects in the universe, not because they are beautiful in the way stars are, but because they embody pure geometry, nature's mathematics distilled to its essence. They are simplicity born of chaos. That's what gives them their quiet dignity. A black hole doesn't resist the universe. It doesn't fight or flee. It simply is. Maybe that's a lesson for us too. In our own small ways, we face forces we can't control. Time, change, loss. And yet, like the black hole, we can accept them not as endings, but as transformations. We can trust that what falls away might still exist somewhere beyond sight. Because everything is connected, every particle, every wave, every heartbeat. The quantum fields that shape galaxies also shape your thoughts. The gravity that bends light around a black hole also holds your feet to the earth. In that sense, the cosmos is not out there, it's within. You are the universe, experiencing itself from the inside. So, as you listen to this, maybe lying back, eyes closed, feeling your breath move slowly in and out, remember this, Fulbrofa, you are made of starlight. You are older than the mountains, older than the sea. The universe is not something you look at, it's something you are. And in that realization, perhaps there's peace, because even if a black hole were to pass through our solar system, even if everything we know someday fades, the essence of it all, the patterns, the energy, the story, will continue. Somewhere, somehow, just as it always has. Close your eyes for a moment and imagine this, Thebro, you are floating in a place beyond time. No stars, no planets, no color. Just a deep, velvety darkness that feels infinite. But even here there is something alive. It hums faintly, like the echo of a heartbeat. This is the quantum field, the invisible ocean beneath reality. It never sleeps. Even in perfect darkness, it trembles with possibility. Tiny fluctuations ripple through it, sparks of creation that flicker in and out of existence. Physicists call it the quantum vacuum, but that name is deceptive. It's not empty at all. It's full of potential, full of the seeds of universes that might one day bloom. And perhaps somewhere in this quiet infinity, a single ripple begins to grow. It expands, slowly at first, then faster. Space stretches, time unfolds, and light returns. A new universe is born. This is one of the great possibilities suggested by modern physics, that black holes might not only be the ends of worlds, but the beginnings of others. That inside every event horizon lies a bridge, a tunnel, a portal to new space-time itself. No one knows for sure, but the mathematics suggests it's possible. Maybe the singularity at the heart of a black hole is not a point of destruction, but a point of transition, where the known laws of physics surrender and new ones take their place. In that sense, every black hole could be a kind of womb, an opening through which the universe renews itself. Every death could carry within it a birth. Every ending could be the start of something unimaginable. And if that's true, then even the final black hole's last whisper of energy, that faint glow of Hawking radiation in the far future, might not be an end at all. It could be the seed of a new beginning, a new cosmos arising from the ashes of the old. It's a humbling thought, isn't it, that the same processes that will one day dissolve everything might also create everything anew. That destruction and creation are not opposites. They're two sides of the same cosmic rhythm. Quantum mechanics and gravity, two of the universe's deepest languages, are still trying to speak to each other. We don't yet understand how. But perhaps, when we finally do, we'll find that they've been saying the same thing all along, that reality is not linear but cyclical, that there is no final curtain, only transformation. And if that's the case, then our black hole, the one we imagined passing through our solar system, might still be out there somewhere, carrying the potential for rebirth inside it. A silent traveler, holding the blueprint for the next great act of creation. Maybe, long after our universe has faded into silence, the gravity of that black hole will fold in on itself, and a new explosion of light will burst outward. A new Big Bang, a new story, a new sky. And maybe, in that newborn universe, there will be new stars, new worlds, new beings who look up one night and wonder, "Ibri, what happens when a black hole passes through a solar system?" They'll ask, as we do now, and the circle will begin again. Because that's the nature of reality. It loops, it dreams itself endlessly, through space, through time, through consciousness. And through it all, one truth remains: nothing is ever truly lost. Not the light of a star, not the life of a world, not even the quiet thoughts of those who once looked into the night and felt awe. Everything that was, still is, somewhere, transformed, remembered, held in the vastness of what physicists call the wave function of the universe. So as the story slows and the darkness deepens, let yourself rest in that idea. The universe does not fear endings. It knows they are only pauses, quiet moments between heartbeats of eternity. The stars are gone now. The black hole's journey is over. The universe has folded itself into silence. And yet here you are, breathing, listening, existing. That in itself is miraculous, because in all the endless darkness, there is still this small, shining point of awareness. You. The same consciousness that once wondered about the stars, that imagined black holes and galaxies and the birth of time itself. The same quiet intelligence that can hold infinity inside a single thought. Everything we've explored, every explosion, every collapse, every whisper of light and gravity has led here, to this moment, to this heartbeat. Maybe that's the hidden secret of the cosmos, that for all its vastness, it still finds a way to express itself in something as delicate as a thought, as fleeting as a dream. When you imagine a black hole passing through our solar system, it's not just a thought experiment. It's the universe imagining itself. It's space-time thinking about space-time. It's energy reflecting on what it means to exist. That's what you are, not separate but continuous with everything. You are made of atoms that once burned in the hearts of stars. The hydrogen in your breath has been circulating through the galaxy for billions of years. The calcium in your bones was forged in the last breaths of dying suns. You are the cosmos, aware of itself, and perhaps that's the real reason the universe exists at all. Maybe it created stars and planets and black holes not just to play with matter and energy, but to one day give rise to awareness, to see itself, to question itself, to fall in love with its own mystery. That's what consciousness is, the universe waking up and looking in the mirror. So even though the story of black holes can sound like an ending, an obliteration, it's really a love story between light and gravity, between creation and dissolution, between knowing and not knowing. And in that balance, there's peace. When you look at a black hole, you're not looking at something foreign or frightening. You're looking at a deeper part of yourself, the part that knows silence, the part that understands impermanence, the part that can let go. Because just like the stars, just like galaxies, we too are temporary. We shine for a while, we burn, we change, we fade. But the energy that animates us, the awareness that sees and feels and dreams, that energy doesn't disappear. It only transforms. Maybe one day, long after our small world is gone, the atoms that once made you will drift through space again. Maybe they'll become part of another world, another being, another consciousness wandering about the stars. And maybe, in that moment, something ancient and familiar will stir, a quiet recognition, the same curiosity, the same wonder, the same awareness. It will look into the night, see the distant dance of galaxies, and ask once again, Ibrishri, what happens when two black holes collide? What lies beyond the horizon? What does it mean to exist at all? And the universe will answer softly, as it always does, not in words but in motion. In the slow swirl of matter and energy, in the shimmer of quantum fields, in the pulse of life wherever it arises. It will say, I am still here, I am still becoming. And in that becoming, everything begins again. And now we return. The galaxies, the stars, the black holes, all of it begins to fade into the distance like a dream slipping just beyond memory. The hum of the cosmos softens, and the vastness that once felt infinite now folds gently inward until there is only you. You and the sound of your breath. After all the light and gravity, all the birth and death of stars, it comes down to this small, steady rhythm, the inhale and exhale, the movement of air that connects your body to the same universe we've just explored. Because the air you're breathing right now, the oxygen in your lungs, was made in ancient stars. Every breath you take is the continuation of their story. Every heartbeat is the echo of a fusion reaction that began billions of years ago. And maybe that's why, when we talk about black holes and galaxies, it doesn't feel distant. It feels intimate. Because the universe isn't something out there. It's something within. It's not a spectacle, it's a home. So, as you lie there listening, imagine yourself not as small or insignificant, but as essential. You are part of the fabric of everything. The same laws that govern black holes govern you. The same mystery that gives birth to galaxies gives birth to your thoughts, your dreams, your quiet moments of awe. There's a kind of peace in that, a sense that no matter what happens, you belong. You always have. If a black hole ever entered our solar system, it would be terrifying and magnificent. It would reshape everything. But even then, even in that unimaginable power, the laws of nature would still hold. There would still be order, pattern, meaning, just in a different form. And maybe that's what we can learn from imagining it, that change is not the enemy. It's the pulse of existence. It's what turns stardust into consciousness, what turns endings into beginnings, what turns silence into song. So tonight, as we step away from the cosmic and back into the human, let yourself rest in that rhythm. The rhythm of transformation, the rhythm that connects you to everything that has ever been. You don't have to understand it all. You don't have to solve the mystery. It's enough to feel it, to let the wonder settle softly in your mind, like light fading on water. The black holes, the stars, the galaxies, they will continue their endless dance. And somewhere, far beyond sight, another story will begin. But for now, this story, your story, continues here, in the quiet of this moment. So breathe in and let the universe breathe with you. Breathe out and let it all go. You are safe. You are starlight. You are part of everything. And as the last echoes of this journey fade, let me say from this quiet corner of the cosmos, Ibrika hello, and thank you for being here, in this space for sleep. If you've enjoyed drifting through the universe with me tonight, consider subscribing, liking, or sharing this little pocket of calm with someone else who loves to wonder. It helps the channel grow, and it helps more people find their way into the quiet. Until next time, may your dreams be as wide as galaxies, and your thoughts as gentle as starlight. Good night, traveler of the universe. Sleep well